There we go. Okay. I messed up, and I didn't set up my game capture on KSP correctly, so let me fix that, and we can look at some beautiful, beautiful code while we wait. Hey, Starfighter, welcome in. Always good to see you. Okay. Off to a great start yesterday and today. Let's do OBS VK capture. KSP. Now, if I go to the game stream, see if this pops up. This was supposed to happen in the background. Hey, there we go. Okay. Yeah, it always takes a hot minute with heavily modded KSP. While that's loading in the background and my computer is trying to put itself in orbit while Patch Manager does its thing, I want to start thinking about my current code situation. I really do want to start working on moving some things into libraries, and especially getting some reusable functions around, like, getting into, if at least not orbit, you know, having first stage burned out with the right apoapsis, etc., 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 etc. And that means writing some more complex things, but also moving some things into libraries. I need to start moving things into libraries. I need to start thinking about this like a real coding project. So that's going to be part of today, is taking the orbiter stuff, breaking some stuff into functions and starting to move it into libraries, as well as I want to replace this, like, target pitch. Do I like namespaces or not? I was digging through the code here, trying to figure out. Oh, and there's the music. So I assume that means KSP is loaded. I have been deciding if I want to try to do namespaces or not. I know there's a way to do namespaces, but I can't find it. Is it under user functions? Maybe. Nesting functions inside functions? No, I don't know. This is one of my frustrations with the KOS documentation, is it is all written with the assumption that you are not a developer, and I frequently struggle to find the things that I want. It's like the files and volumes section doesn't actually have any information on how to do anything. It's under commands file IO. Yeah, if you can find an example. Otherwise, I'm just going to use run once path, and we won't have namespaces, and I'll worry about it later. That's... Because I think, you know, in theory, if I just make a lib folder... And then in boot, I want to do like a new Kerbascript file. We'll call it orbiter new. And then I should be able to all of my standard boilerplate at the top. Just something like that, right? And then I have a redstone library, and I can put the redstone basic things in it. And then the orbiter specific stuff. But it would be nice if I could do namespaces, so I could do like redstone dot something or redstone colon something or whatever. Are they doing something hacky, like creating a what are they called? Creating a lexicon of delegates? Is that the way you would kind of create a namespace? Yeah. Okay. Yeah, so like then in my lib folder, create this. I do global redstone is lexicon. Redstone add of launch. And then whatever I need to do to actually declare a function, I have to double check the... Awesome. Thank you. Let me find that link. Global lex of thingy, local function. Perfect. That is exactly what I want. So then we're going to have local function launch. Parameters are target PE and initial pitch. And then to do. And then here, is this run once path still the best way to actually load the file as a library? And then I do redstone, however lexicons work. You could call without use parentheses. Yeah. And lexicons can use suffix to text. Cool. So then I would do redstone launch, whatever our target PE is, say like 250K. Oh, I wish I could do that. 250,000. And what was the other one for doing a simple? Yeah. Yep. Redstone launch to the target PE and whatever our initial pitch is in degrees. Okay, cool. And then that will actually do its thing. We're launched here. And then it's going to be, you know, some other stuff. Wait until our ETA, lock to prograde, a bunch of other stuff. But now all I have to do is write the redstone launch code that will... Can I get this to decide this is a string and highlight it? Or am I just going to be in... There we go. Okay. And then this actual code... let's see. Oh, I guess I should also have a... Let's see. User functions parameter. Oh, and I can do... Okay. Target PE, initial pitch, and then heading is 90. That way it'll always... It defaults to going east, but it'll figure out... And then... In this launch, we want to pitch over in target direction, lock to prograde, gravity turn until space, pitch more aggressively to target PE. That's a gravity turn mission profile. I'm hoping I can get a few meters a second more DV out of this thing by doing a real gravity turn. So we're gonna try it. Worst case, I give up and I copy in this thing, and maybe I should just start with this in the librarified version, but... Okay, so what we want to do is we want to set an initial target pitch to get us up to our initial sort of target velocity. So we do like local function initial target pitch heading, and that's gonna be, we don't care about the fuel, we don't care about emptiness, all we care about is the heading. And I guess the initial pitch should be, yeah, 90 minus this. That's fine. I have no idea if this works. Nesting functions inside functions. Yes, it does say it works. Okay, so the initial heading... Oh, I don't even need this to be a function, do I? I just need to do, like... countdown, wait, sorry, stage, lock, steering to heading of heading 90 minus initial pitch. Zero. Okay. So this will pitch itself over. And then I want to wait until ship this just waits until angular velocity orbitable. Is that what I want? Yeah. Okay, heading, compass heading, pitch above the horizon. So should that be identical to surface prograde then? Will staging be handled at the call site? Yes. So my plan was to do some combination of coroutines and staging. I think I want to have this like launch function not return until it's done. So like here, but like if I was doing my atlas, I would set up a like when, you know, Parallax less than threshold drop booster engines, right? And same with like strap-on solids or whatever else. All of that can be done in the ship's like own launch profile, and then in theory the main control program just keeps running. Okay. So it's like wait until ship. Here, let's see. Local target is heading. Lock steering to target. Wait until ship. Yeah. Wait until Vang of ship prograde vector target prograde is less than yeah, exactly. I'm trying to be staging is not agnostic in the guidance, and then oh, you're right. But we do have roll control. As long as we have roll control, it'll be fine. But you're right that it would be better to use something else. Yeah. Although this is just the angle. I'm specifically using the prograde vectors, though, not the Sorry, this should be 4 vector. If I'm using the 4 vector, there you go. This is just the angle between the vectors, right? So I want to make sure they're pointing in the same direction, because 4 vector won't have roll. This should work, assuming I got my like vector conversions for the headings correct. And actually, should probably be the surface prograde. It's pointed to the target. Is that what I want? Go back to the orbitable. I could do that, but then the heading... Ooh, that's bad. I just realized that this really should be on the other side. So that... Oh well, I'll deal with it another time. I just realized the white text on the white of this documentation is bad. Oh, I'm sure my syntax is awful. I'll figure it out. Anyway, what was I saying? Heading is 90 because I don't want to have to worry about what rotation I build in the VAB. I know some people might find that convenient. I would find it annoying to have to like rotate the ship in the VAB for my launch azimuth. Anyway, orbitable. I want surf prograde, which is a direction, which has a 4 vector. Oh, the is facing. Yeah, that is absolutely wrong. I was like, that's... Parameter, target, heading. Wait until target 4 vector and heading 4 vector. Vang returns what? Return type scalar. Yes. I'm going to assume it's degrees. Get within half a degree of our target. All right. And then wait until is facing of our target and ship surface prograde. Right, because we get heading pitch above the horizon. And then where is it? Pointing in the direction of this object's surface frame velocity. Yeah. I think I actually want to do this. Because I think, and this is where I wish the documentation on this was better, but like heading... Heading is in the surface coordinate space, right? It doesn't necessarily make that clear, but like degrees from north and pitch above horizon, it's in surface relative. And if the ship is, I mean, technically we're not moving that far, like across the surface during the initial launch, but I still think we want to track that to avoid any... That's true. There's probably KSP documentation on it. I should probably stop trying to overthink it and assume that, like, KOS generally has stuff that works together because it's designed for people that are not super knowledgeable about this stuff, and just test it and see if it works and stop worrying about it. Okay. Yeah, so we lock steering to heading, and we wait until we hit that heading. Now, lock steering to ship prograde. Wait until ship a good programmer thinks about the corner cases that are relevant to the problem they're solving. If you think about all the corner cases, you're going to waste your time. What am I looking for? No, this is almost certain orbitable that I want. Because it's always orbitable that I want, not ship. I mean, I could just use altitude. Oh, here we go. Atmosphere. Height would be what I want. If I wanted to be generic over... And then... Yeah, on other bodies it'll matter. I was just like, do I want this to be generic? And by the time I'm writing anything that's like taking off from another body, I'm not going to worry too much about it. Okay. So from the white paper that I linked in the Discord last week or over the weekend, it seemed like the way NASA did early launches, including Explorer 1, which is what this launcher basically is still, was you start out with an initial pitch over, pretty rapid, when the ship is still... you pitch over pretty rapidly when the ship is still moving slowly and angle of attack doesn't matter. And then you naturally always want to have yourself pointed in your prograde vector. So your ship will be pulled down by gravity, and you want to lock your steering to that vector. What that paper did was talk about how you can predict all of that based on, like, the weight of your ship and its thrust and its gravity and all of these things. And what they would actually do is they would do a lookup table for, like, the angle of the thrusters and, like, bake all that in, because at the time they didn't have, like, a gyro in there. They weren't doing tracking. But because we're already running inside a numerical integrator, which is the KSP physics engine, I think we could just lock steering to ship prograde once we pitch over a little bit initially, and it should just work. That's my hope. And it should just do a gravity turn. Is there a gravity turn tutorial, by the way? No. There probably is in the example libraries, but I've been trying to avoid it. Let's see. Examples. Id, blah, 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 blah. Maybe not. Why can I... Oh, right. GitHub's obnoxious, and I'm not signed in this browser, so I can't do anything. Can't search if you're not signed in on GitHub. Anyway, once we're above altitude, above space, and actually we don't necessarily have to wait until we're above space. We could set this to something lower. When the atmosphere is thin enough is really the thing we care about. We want to start having our pitch relative to our periapsis, so that we don't overloft ourselves and we just pitch over more aggressively as we go. So when I look at the orbit struct, has a periapsis height. But what I really want is, like, the... Well, and it'll actually be apoapsis here, right? Because we're in the first half of the launch, so our apoapsis at initial launch will be our periaps at... once we do our actual orbital burn, right? I think what I need and this would is where a node would be great, right? Because I could do a maneuver node. Make it, you know, it doesn't matter what the prograde is. 1 meter a second prograde. And you would get the direction that you would burn in, right? And that's what I want, is I want the direction we're going to be at AP. I should be able to actually compute that myself from the argument of periapsis and orbital period. Yeah, so I think I'm going to have to compute that myself from these orbital things instead of just being lazy and making a waypoint, because I don't have waypoints unlocked yet, or not waypoints, maneuver nodes, and I won't have them until lunar tech. I mean, the other option is to just not have this wait until... Let's see. Do we have like a ship? Why would I say is there? Oh, maybe it can create a node struct, just can't add it to a flight plan. Okay, let's try that then. So instead of that, we say wait until ship... One second. Do I have like a engine or a stage like burn time? There's a burn time on stage. Okay. Are you sure? Oh, there's a delta V struct. Okay. How many seconds at max thrust will emit this delta V? Okay. There it is. So it would be like... I probably don't have to do that, do I? I probably don't need to know about the delta V. I just have to... What do I want? I want our target pitch to be completely vertical to completely PE. Let's start with node. Let's see if I can make the node first. So set, actually, let's do this. Local function burn to PE. No. We're going to make this a function. Okay. Because I'm going to want to update this, because every tick as our orbit is changing, our time to our AP will change, which means that we need... we need to recompute our node, etc. So we're going to have, like, ship, orbit, ETA, local AP ETA is ship, orbit, ETA, apoapsis. And then we'll make a node. Local target dir is node of, let's see, time span, a time stamp, or a scalar. What do I actually get out of ETA? Seconds from now until apoapsis. Okay. So I need to make that into a time span? Is that what I want? Maybe? Yeah, radial, normal, and then prograde. Thank you for making this 0, 0, 1. I don't actually care about the velocity. I just need to know its direction. And then I want the prograde from that. No, I want the burn vector. Sorry. And then I don't actually want heading. I want to use, like, I think looked-er up of okay. Yeah, I think all I'm doing is a time span as an interval, and I'm taking AP ETA that is already an interval in seconds, so it should work. But if it doesn't, I'll take yours. Looked-er up of the dir is target dir, and our up is... Can I just get my, like, up vector? Orbitable. I want, like, my current up vector. Not as a direction. I think I want, like, orbitable... No, I want ship. Sorry, I want my ship's thing. Yeah, that's right. I want orbitable. Ship. Prograde. Let's try that. I'm just trying to make sure that I don't induce any roll and that we get a clean pitch over. Okay, and then what I actually want is... Oh, and this is wait until ship altitude is greater than 140,000. And then I want to have, like, local... All right, so if our local AP dir is... All right, so then I need to, like, not an equals sign. Try that again. When we cross the 140-kilometer boundary and we switch from gravity turn to just steering ourselves, what we want is to interpolate between power pitch and the... I want a slurp. I know what I want is a slurp. I just don't know if I can do it in this. Right? I have two directions. I have our prograde when we left atmosphere, and I have whatever our prograde will be at apoapsis. And depending on how close our AP is to the target AP, I want to pitch over further towards the AP. Maybe I can do this with, like... I was just going to do it based on the altitude. So, like, we have between 140,000 and our target altitude. We are somewhere along that line. as our target altitude. I'm trying not to do any of it based on time in this one. I want it all to be based on, like, altitude, where the AP is, and all those things, so that it's reusable across ships. But, like, slurp based on, again, how close our target AP is to the current AP, right? So we're going to have, like, ship, orbit, yeah, apoapsis minus divided by target PE minus, right? And again, I'm writing Rust. Local. Okay. So, like, we have this number, this normalized AP. Yeah. And then what I want to do is... You know, actually, local space prograde is ship prograde. Okay. Now, we have our AP dir, and we have our ship prograde dir. And what if I do something... Does this have an interpolate function, by the way? Or do I have to write it myself? It's not hard to interpret to write it myself, but... language, flow control variables, general, no. Mathematics, here we go. Scalars, operators. No, I don't think this has. Yeah, I can do it from memory. I just was hoping I didn't have to. Local function lerp parameter a b t return a times t, no, a plus b minus a times t. There we go. Want to see something really absolutely disgusting? Because I'm about to do it, and we're going to see if it works. Return R of lerp between our initial space prograde and our... yaw, and... Oh, it absolutely doesn't. Like, if our ship AP goes high, this will get weird. But I normalized it, so it should be okay. And actually, I'm going to put the time in first. I'm going to make a lerp-dir function even. Pitch yaw roll. This isn't a true, like, slurp. A plus, oh, B minus A. That's probably what you were talking about. Yeah, so at 0 we want A, at T1 we want B. If we're above T1, then things get weird. But that's okay. And then lerp-dir just does that for each component. This is not a good way to smoothly interpolate between directions. I want to be really, really clear about this. Can I get pitch, yaw, roll, all the vectors? What I would really like... Yeah, I could use the vector mult. That's... Yeah. So it would be like local avec is v of a dot pitch, a dot yaw, a dot roll. I don't know if that's worth it. What I'd really like is to be able to get the quaternion out of a heading. Oh, it might already be vector capable. That's true. So then it would be like lerp of t. I don't know. Is that clearer? Maybe. I think this is clearer. It uses a few more cycles, but, like, honestly, my computer's powerful enough, I could probably throw a couple of zeros at the end of the, like, cycles per game tick and not notice any slowdown, so I'm just not that worried about it. A and B in lerp-dir are directions. Yeah, not... I mean, I guess I could do them with the 4 vectors instead. So instead of lerping directions, I would lerp local dir is... Oh, and then I wouldn't even need AP dir here with this look dir up, because this is a target vec. So we'd like lerp space, and actually this could be 4 vector as well. And then yeah, we just lerp normalized AP from space prograde to target prograde. Yeah, there we go. That's better. And then whatever I want to call this, local, I mean just prograde. And then we return a look dir up of our prograde and our Up is ship prograde up vector. All right. Ugh. And then lock steering to heading. And then we need to wait for something. Unlock steering. And that's it. And then we hand control back to the main program. So like if we wanted to be hitting the polar contract, which is my next one, obviously you have to play with the initial pitch a little bit. You could skip this whole section of the code and choose your initial pitch such that your gravity turn does the right thing. This is just ascent. Circularization is going to depend on the upper stages, and I expect my upper stages to change a lot more frequently than my booster profiles. So like here, I would take like all of this. Because this is all kind of vehicle specific as to how you're doing, right, circularization. Once I have restartable upper stage liquid engines, I'll be able to like move that into this stuff. And like, honestly, this redstone launch is, I mean, it's in the redstone booster, but it's probably all pretty generic, and I should move it out of redstone. I don't know if the redstone even needs anything special, right? But that's okay. So yeah, this is like launch into a 250,000. It's the apoapsis here, but it will be the periapsis with a certain heading. And again, this initial pitch number is what defines the gravity turn. And I'm not sure really if this should be a parameter here at all. Is there a way to do a test flight manually and have that automatically translated into KOS? Probably not built in, but I don't think it would be that hard. I think you could pretty easily... Yeah, you could capture the replay, because you can check the status of all the, like, controls, right? You can actually see, like, what buttons the player is pressing. Yeah. Yeah, record pilot inputs and then replay those. Yeah. I think the interesting part would be figuring out how you want to... Because, like, you can record every frame, like, this is the state of every input, and that would be a very big file. I mean, very big. Dozens of bytes per frame for a few minutes to orbit. But then, you know, I think the interesting part is, like, can you translate that to something algorithmic, right? Like, you flew it, here are kind of the key points where, like, the rate of pitch over is changing, or where you throttled things. Yeah. But I think if you could capture the flight profile, again, you know, be able to say like, oh, we're pitching over at this rate and then we pitch over more aggressively, or if we've got throttle changes and things like that, I think you can capture that information, but I'm not sure you would want to do that in KOS. You'd probably want to capture the flight in KOS and then do some analysis on it afterwards. All right, it is ad break time, and I am going to stretch my legs and get a little bit of water while that runs. I will see everybody in just a few moments. All right, I'm back. Hello, hello, Twitch Turbo and YouTube gang. The about 45 seconds left on the Twitch ad, so what I should do is take this opportunity to load back up my game. All right, welcome back from the ad, everybody. Let's actually get into the game. So this is the updated version of the rocket that I made last week. You can see we no longer have the liquid stage. We've got a longer redstone, and we're waiting on the tech for it. Oh, maybe I did get the tech for it. Can I upgrade these? Or I'll have to double check. I might still be waiting on the tech for it, but there's an upgrade to the baby sergeants as well. So this is, at this point, basically the Explorer 1 rocket, and we're gonna try to do the launch, the new launch profile with the new script on this. So we're not using Orbital Simple anymore, we're using Orbiter New. I have no idea what this is gonna do, to be honest. Looking at the code. Something that I might want to do here is add spin up of the booster. I'm not sure yet. On the actual Explorer missions with the redstone and the solid can on top, the can itself spun up. There was a motor, I think it was a motor in the can, that would get it up to speed to deploy the upper stage, but we don't have that. And when I flew this last time, I had a Kraken attack, and I could have reverted it because technically it was a Kraken attack, but it was a Kraken attack I deserved, so I didn't revert it. The issue is that these spin motors, despite looking mostly attached to the can, are actually attached underneath the can, right? Because the can is a, that is not the piece I wanted. Come on. The can is a visual, right? But when the can is in place, it stays attached to the stage below when it decouples. Obviously, I could turn off the can, and I think this would work without Kraken attacks, but that's no fun. I want the shroud, I want it to look good. So what we have to do is fix our staging here so that these motors are no longer clipping through the can, and so that we have enough ejection force so that the baby sergeants are free of the can before we spin up, so that we don't risk the can, like, bonking them. So the first problem I'm going to solve... Ooh, I could put them, like, right there. I kind of like that. I'm gonna tweak their positioning a little bit. Let's get, where's... Fine adjust. Fine adjust. Let's get those in. Make sure that it's not clipping too much through the can again. Then do, like, the rotation in a little bit. There we go. That doesn't look too bad. Relative local. Well, that's not helpful. There it is. All right. I like that. Easy ways to translate testing into KOS. I would say, so one of the things, if you're doing RP-1 is when you hit the simulate, you can choose a body and a orbital parameters. So you can say that, like, your... I don't know where the moon is. I'm looking for the moon. There it is. Moon. In orbit, you know, at some altitude. So you could say you're in a... I don't remember what the right altitudes for lunar orbits are, so I'd have to plug it in. But, like, even, you know, if I just wanted to test, like, my return capsule, right? Like, I can start in orbit of, like, a 250 by 1500 orbit, or, you know, I guess for a camera it would be closer to circular, right? So, like, a camera at, like, a 400 kilometer orbit, right? And I could test just my orbital, like, camera stage and deploy the return capsule and make sure that that deploys. And you could set all the orbital parameters, etc. So as long as you design each of your ships so that they are, you know, able to load in and figure out their state is a big part of it with KOS, right? Because they have to know, you know, if you have... And eventually I intend to move to this, and I haven't started writing the code that way yet, but, like, ideally, this booster knows how to get itself to wherever it's done boosting, and then I can actually set this with a boot file, and set the boot file on this thing to something else, and it'll figure itself out. And kind of let each stage independently know what it's doing. But you have to be able to figure out your situation. You know, if you expect to have had some information transmitted from the booster, then you have to make sure that your upper stage can figure out, like, okay, yes, I am actually in orbit, my situation is correct, all of those things. And, you know, I think adding a little bit of test code around setting that stuff is not too bad, probably. That was kind of rambly, but that is what I would do, and what I will be doing is, like, when I'm testing my lunar impactor, you know, we're going to be starting from Earth orbit and then, you know, testing the impact profile, and then later on when I'm testing lunar landers, you know, the orbiter part of that, we'll start all of that in lunar orbit, test all that, and then, you know, get it on the TLI stage, test the TLI stage. And, like, yeah, it would be good to sim the whole mission, but in theory, you can test all the individual pieces separately. All right. The other thing I wanted to do to try to prevent Kraken attacks on this is to pull the booster apart. So if I just put a couple of these guys... Not there, because those ones are all sad. Okay. If I just do like that, and then they need to fire at the same time as these ones, which is at the same time as... that decoupler? Is that right? Engine, release, decouple, Baby Sergeant 11, decouple, Baby Sergeant 3, decouple, Baby Sergeant 1. Yeah, I would say do it in small sections, right? And that's how missions are designed in the real world, right? Nobody's... Well, I'm sure somebody is running a simulation, you know, full up of, like, what does it look like when you put the next Mars rover on a Vulcan, and how does it get into orbit, blah, blah, blah. But in general, they will simulate each of the mission pieces in chunks, and you want to make sure that each of your computers if you're doing KOS scripts, like, and again, I haven't started doing this yet, I just have one script running on the top avionics, but like, there's nothing that stops me from running a booster script that like sends a message to the probe script when it's in orbit, right? And things like that, so that you can handle deployments and startup code and things like that. You just have to make sure that, like, if your probe startup program is like something probe, you know, it needs to be able to handle, and you need to be able to handle this in KOS anyway, because especially for long-running missions, if you leave the scene and come back, then your startup code runs again. It needs to be able to figure out what situation it's in, right? Is it still attached to a booster? Is it at its final destination? Is it ready to deorbit? And it needs to know that if you're entering and leaving the flight scene. And all of that also should make it relatively straightforward to like simulate each of those situations. Again, if you're relying on like storing data to the KOS file system so that your avionics keeps track of its state, then you're going to have to, you know, fake that data somehow for simulations. But otherwise, as long as it sort of figures out what it's doing, you should be okay. All right, I think these are the changes. I mean, the other thing I could do is, instead of doing all of this with spin motors, plan B would be, because I have the tech now, I don't love the way those look. But since I have the tech now, I can do, two ways. Oh, it's got to be a three-way. Do something like that. And then I think I can switch to nitrogen is 86 newtons with 51. Yeah, I can switch to HTP, which has quite a bit more oomph. And then I could spin it up here, but this would mean having to write code to do the spin up, and I don't necessarily feel like doing that right now. It's the right thing to do, but it's not what I'm gonna do. Although what I could do to help it steer is use bigger jets. We have plenty of nitrogen on this thing, so there's no reason not to use a larger array of RCS. And then up here, go back to what I had before, which is these motors. On top, as well as a cluster of them here to pull the ship back. And then I've got to reposition these again. Okay. And then both of those need to fire at stage 3. Right, because that's when, yeah, this decouples, this will stay with the stage below. And then these guys all launch. All right, so hopefully with this pulling back using these thrusters, I don't know if this is enough oomph. We'll find out in the sim. But hopefully that avoids the Kraken attack that I had when I ran this the last time. And actually what I'm going to do is I'm going to test one thing at a time. We're going to use the same KOS script as the last attempt. We're not starting in orbit. All right, let's sim this, and then we're going to realize that it's the middle of the night, and I needed to put a time offset in, and this sim is going to be awful. Oh no, it's actually fine. All right. So all I'm looking for with this sim is that when we decouple the can, we have a clean separation before anything else happens. All right, and then we're gonna get closer to AP, and this should try to orient itself. Hopefully a little more quickly now that I'm using the double thrusters, which I should have been doing from the beginning. I think it does that at 2 minutes to apoapse. Or I guess it's apogee. Oh yeah, look how quickly it stabilizes itself with bigger thrusters. What a shock. So that's good to know. I can fix that in later scripts to not need that. And then when this fires itself is what we want to see. Yeah, that looks good. There we go. Predicted apogee, 600 100,000 meters. Perigee, 330,000. Beautiful. Okay. And that separation looked decent to me, which is what I wanted to see. Making sure that the spin is happening and the ship is being pulled away and nothing is bonking around inside the can. Large shrouds like this that are a tight fit are how you get pet Kraken attacks, right? So making sure that it pulls out cleanly is good. So now we switch over to the new boot file, and we all learn how bad I am at writing code without a compiler to tell me about my typos. Yep. Bonk. I wasn't expecting it that quickly. Unexpected token. Expected. Oh, because I didn't actually finish writing my code. Okay, so we need to wait for what? Ship thrust to be 0. Right? Vessel has thrust. Yeah, sum of active thrusts. Ooh, will that work with RCS on, though? That's the other question. Oh, but we don't turn RCS on until later. Oh, I'm not even using this target prograde, which I should be using. Alright. But that does mean that it got until, like, some part of parsing this, at least. Alright, let's try it again. You might be able to fine-tune an AI on craft files and how to fly them. I don't know if you would need an AI, to be honest. Like, once you have a library of functions around, like, orbits and understanding stages and stuff, I mean, MacJeb can fly most rockets just fine. The only reason MacJeb has trouble in RP-1 is because engines don't throttle. In base KSP, MacJeb can fly everything. What? Oh, I needed an until. Whoops. That was... Yep. Yeah. Oh, well, this time I have no idea what the error is. Countdown. Oh. I never actually made countdown a function. I started to, and then I got distracted. Yeah, I definitely think it's possible for an AI to do that stuff. It's just, cannot find label countdown. 6 to... what? What is that error? Oh, is this because I have a variable that's named the same as the function it's contained in? Is this my problem? Let's see if this works. If this doesn't work and I have actually managed to uncover a bug in KOS, I'll be impressed. Not allowed to set a name that will clobber or hide the built-in function. Ah! That's fair. You know what? Well, I suddenly don't care about this part. Is where I'm how I'm feeling right now. The 3-2-1 is fun the first time you write a KOS script, but I don't need it right now, and I don't want to debug it anymore. Lock steering to... must attach node first. Okay, that's what I was afraid of. Let's see if I can still do that. Okay, let's double check the node stuff. Orbits... no. Node. Maneuver node. Just add it. Remove next node, has node, all nodes. Only blah, 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 blah. All right, let me reread this career limits. If you cannot add maneuver nodes. Okay. So I can generate the node struct, but I can't get the things that I want off of it without... That's annoying. I mean, I could try to add it, but it's not going to work. Oh, I wonder if it's because I'm looking at the burn vector. Like, does this tell me... mean... This is probably not going to work because I don't have... I'm going to run it, and it's going to break. But I just want to confirm that it breaks. And I expect this to error saying that it can't find a node. Yep. I need a better mission control building in order to use maneuver nodes. Blah, 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 blah. Okay. That stinks. So, how do we generate our target prograde without a maneuver node? That is the question. We have our orbit. You know, I wonder if there's anything in the example library that already does this. Library, what? Real shoots, string to num. What is this? Between geographic coordinates, that's not what I want. Circle nav. Oh, great circle equations, also not what I want. All right. So one thing that I could do is just this. We lock the steering to prograde, we do a gravity turn, and all we do is we tweak this initial pitch number until it does what we want. We avoid everything else. So then we just have to tweak our gravity turn parameters, and it's doing a gravity turn the whole way up. Which, once we no longer have, once we're out of the atmosphere, is not necessarily the most efficient, profile. Like, it's efficient to do a gravity turn in the atmosphere, because you want to be pointing at your prograde vector. That's how you do work. Nope. How are there still issues? How are there always issues? Undefined variable name target. What did I do? Is facing. Oh, I see what I did. Back to the code we go. We don't have a target here. I want to do this. Local target is heading of... Oh! Yeah, that's right. I said I needed to do this here because... Wait until is facing of... Yeah, because we want to recompute... There's a better way to do that, but I don't care. This should do what I want now. And that it's recomputing the pitch every frame based on our surface everything. So in theory, we should get a gravity turn. Or it'll pitch over 10 degrees. We should see it pitch up 10 degrees. I remain bad at writing my own programs. Okay, what do we need here? We need wait until engine thrust. Yeah. Let's turn this off. Can I make this more generic by finding... Actually, yes. Let's go back in here. Let's go back into KOS. Okay, this says it's an ROE A7. And that is what I was afraid of, is that it depends on the... Well, wait, no. I thought I was running Hydyne in this one. Yeah, the configuration is A6H, but it's always an ROE A7. Okay. We are definitely not winning, but we're getting there. So, unfortunately, the node code doesn't work right. It doesn't work even with if we don't add it, because we can't get the burn vector until we add the node. So I'm going to have to play around with other options there. For now, I'm just trying to get the gravity turn part to work. And I just realized that I missed some important parts of local engine. We're not going to use parts tagged. We're going to use parts dubbed because it's the ROE A7. And we're going to launch, and then we're going to do wait until we're at 90% thrust. There we go. And then we do our pitch over. Wait until that pitch over is done. Then we lock to prograde, and we should just do a gravity turn. If I see us do a gravity turn, I'm going to be happy. If I can get our... In theory, I can adjust this and we can do a gravity turn the whole way up to our preferred PE. I just have to tweak this initial pitch number. But it would be better to do... You know, once we're in space, you can do more efficient things than just a straight-up gravity turn, but it should work for now, assuming no more typos. Okay, there we go. Bravo. We will not go to space today. All right, what the heck did I do? Did it just pitch over too aggressively, or did I set the... Yeah, maybe I need to, is there a way to control the steering rate? Do I just need to set something a little less, insane? Steering manager... Oh, we also have, like, pitch and yaw and roll errors in the steering manager. Instead of using this, like, is facing thing, I can just check those. Wait until... I'm gonna do this. Let's see. It'll be steering manager. Oh, roll is the one that I don't care about. Yeah, we might want to have a little bit of a delay on our airspeed, because there's, like, we need to be going fast enough that we're starting to be a little more stable, but still slow enough that we can pitch over without tearing ourselves apart from aerodynamic forces. And then, once we do that initial pitch over, we can follow the gravity turn. This should be pitch error. Cool. I had no idea that these parameters were here in the steering manager until just now. Vessel currently steering towards... Oh, nice. Yeah, this has a bunch of stuff. But yeah, so let's just, like... Let's just wait 2 seconds before we try to steer and see if that helps. Well, it did wait. I'm not convinced that was steering fast enough that it should have failed like that. Did I write the wrong target? Am I just bad? We want our heading, 90 minus initial pitch, because initial pitch should be whatever, and then 0, right? And that's what we're doing here, right? Heading, pitch angle, which is 90 minus our pitch over, 0. Yeah, I'm going to debug the target vector. That's a good... Show facing vectors, we don't need the rotation vectors. We just need the facing vectors. Well, no, that's the facing. Can I see the target? Oh, yep. On. So that should always show our current facing. How do I see the target vector? Drawing vectors on the screen. Here we go. Yeah, vecdraw of the start is going to be like ship position. I know that's not the right syntax. Our actual vector is going to be... No, wait. Vecdraw of... Start, I'm going to have to figure out again. Ship position. End is going to be steering manager target for vector. RGB of, I don't know. Can I just draw steering? Oh, I don't know. Can I just draw steering instead of some internal steering manager stuff? Maybe. Oh, yeah. Oh, I didn't even think that I could read steering. That I never thought of reading like that. Yeah. Yeah. Maybe. We'll find out. I guess I've always treated steering as like black magic. All right. And then orbitable. Can I get like... Sorry. Vecdraw. Drawing vectors on the screen. I don't want a... Start optional. Oh, in ship raw coordinates. Okay, so it is just V000. Okay. Let's find out if this does what I want. It probably won't. It's possible that we're still pitching over too strongly. Because don't forget, once we pitch over, we start following the gravity turn. And maybe we're actually getting into the gravity turn part, and 10 degrees is just way too aggressive for this rocket. Unexpected token T found. Parameter target PE? Oh. Yep. I had a typo. Not gonna switch over to the other screen and show it. Cannot use Boolean where scalar is... what did I do wrong? Thought I copied everything. 1.0 true. Oh, nope. I missed a couple of parameters. Whoa. Well. So yes, our steering vector is correct. I have a thought. I'm gonna turn off this show facing vectors as well. What if we just like wait 5 more seconds before we lock to ship prograde? I'm wondering if what's happening is we're hitting our heading. We're still pitching because it hasn't had time to stabilize because our angular velocity... Oh, steering lock should probably check angular velocity and not just the pitch error. That's important. But also... Yeah, actually, let's do that now. Let's fix that. Can I get that from the steering manager? Probably not. No, I gotta get the orbitable... angular velocity. I know that I used angular vel somewhere. Yeah, ship angular vel. Okay. Let's see. Local angle good equals local rate good is... Okay. Let's also try this. Let's just set it to 90. Also, Twitch is starting the hourly ad break, so I'm gonna just try to launch this as is, and then I will not mess with it anymore until afterwards, after the break. Yep. Okay, I figured out the issue. Still an hour and a half on the minute and a half on the Twitch ad break. I'm actually going to step away for a second, and then I will get it fixed when I return. What did you do to Jeff that he punishes you with 4 ads? It is the bare minimum ad break time that I can do to fully disable pre-rolls so that people can come into the stream and be able to see what's happening and hang out. That's, alas, the situation. Anyway, I figured out what broke, or at least part of what was broken. This needs to be surface prograde, not prograde, because of course we're pointing to the horizon, because at the start our entire orbital velocity is just the velocity of our, rotation from the day-night cycle of the planet, right? So this is part of it. So in theory, we now should be able to do of like 90 minus initial pitch, and 10 is going to be way too aggressive. I knew that this 10 degree, wherever I put it, orbiter new, here, this 10 degree pitch over is going to be very aggressive. And the other thing I fixed is I have this wait until steering locked now takes into account angular velocity as well as pitch error. So it should hopefully see if we can get this to behave a little better. We should go up for 2 seconds, pitch over to 10 degrees, go forward for 5 seconds, and then try to do a gravity turn. Pitch over, yep. Yep, and then we lock to prograde, and we do a gravity turn. It's just a very, very aggressive gravity turn. Bravo. Okay. At least it's following the profile it's supposed to follow. Okay. Yeah, I need this to be able to hit the polar orbit, but ideally the script will work for everything else. But the polar orbit contract is the next one that I need to hit, so. Close some of these other ones that I'm not actually using, so I stop clicking on them. Okay. So I added this delay as a parameter. This is how long the ship stays on its initial pitch with steering locked before we relock to prograde. That way that's tweakable, and the initial pitch is also tweakable. This rocket kind of heaves itself off the launch pad, so I think we want a longer delay for it to get itself to, or moving a little more quickly in the right direction before we let it follow prograde. And maybe we should do that as like a target altitude instead of a timed delay, but we will see. Oh yeah, because when we pitch over, we immediately get a lot of sideways velocity. Yep. I mean, again, doing a gravity turn, just not the gravity turn I want. I'm starting to understand some of how this works, though. Because when we're steering even more than a small amount at the start, we're getting a lot of horizontal velocity, right? Because all of our steering is from gimbaling the engine. So what we might want to do instead is just accept that we're going to get that horizontal velocity and build it into how we choose our angle. So I'm going to get rid of this delay. And we're going to set our epsilon here a lot smaller because orders of magnitude matter. And we're going to only pitch over like 1 degree. Yeah, it's probably in just a couple degree range. Make epsilon here. I'm actually going to go all the way down to 0.01. Hopefully it can stabilize. I should add a debug print. And then this weight 2 is really just like a clear the pad. How reliable, repeatable is that going to be? I'm not sure. It should be relatively reliable and repeatable. You know, I think the question is, how does it, like, flick the engine, right? Because, like, that's what we're seeing, is that our initial pitch over comes from the way it flicks the engine that gives us that, like, sideways boost. You know, we're not quite power sliding off the launch pad, but kind of. And that's going to vary by booster design and by how tall the rocket is, where its, you know, moment of inertia sits. So it's going to have to be probably tweaked per vehicle, but I think the general concept of it should be okay. Oh, the epsilons? We'll find out. Yeah. I mean, worst case, I will need to start writing some of my own steering controls around how we pitch over at start, how we're using the engine gimbal. I've been expecting to have to do that eventually anyway, but... Whoop, what did I do? What did I do? Come on. Oh, I got rid of the delay parameter and then I didn't change the orbiter new code to get rid of it. That's what I did. Okay. All right. 2 seconds. Pitch over. Man, even 1 degree is way too aggressive. Yeah, also the wrong way. How did that happen? Alright, so our initial pitch is... I'm going to do 2 degrees instead of 1, just to give it a little more. And I'm going to wait longer off the pad. We're going to, like... Let's do 10 seconds vertical and then pitch over. And what I'm hoping to see is that our velocity will be a little more... well, vertical. Right? We want to be, like, just pitched over a little bit and then let the gravity turn do its thing. Oh, at launch we're not locking steering vertical. No, I should do that. So yeah, that's probably part of the problem. Is at launch we might tilt a little bit. Heading stable, switching to gravity turn. Again, going the wrong way. I mean, the last time we had a nice stable launch, we were completely horizontal by the time we hit this altitude, so, like, progress has been made. But this is, I don't think this is a going to space trajectory. One, because we're going south. And I don't know how that just happened. Okay. So yeah, in our initial weight, when we just want to go up, we do want to lock steering to heading of this. Weight 10. Wait until that's locked. Wait. You know, I'm starting to think that I want to wait. Probably what I want is wait until ship surface val is greater than some number, right? We want to hit a nice stable, like reasonably aerodynamically stable number. 500 is probably too small, but let's check it out. Oh, of course. Oh, surf vel is not a real thing. God. It's probably like spelled out. Surface vel or SRF velocity? Which one do we think it is? Oh, it's right in front of me. Velocity. Oh, I want velocity surface. Of course. Okay. And then, again, 500 is probably too small, but I'll play with it and see what we get. And what did I do this time? Cannot... Oh, my velocity's a vector. Ugh. Is there a speed suffix instead of a velocity suffix? Is that what I need? No. Vector.mag. Yeah. I feel like there should be a better way to, like, just get the number that I'm seeing in the UI than all of this. But whatever, it'll work. Yeah, the vertical velocity, but that's not really what I want, right? Although it doesn't matter. Alright, and then we pitch over a few degrees. And we see... I'm trying to zoom in on the nav ball as if that'll work. We should see our prograde vector kind of be pulling itself up along the nav ball closer to this velocity that we're pointed in. And it is. The prograde vector is correcting itself a little bit. So this might be fine. 150 actually might be too big. I thought it was going to be too small, but... I mean, really what we care about is Q, right? We care about when Q hits a certain threshold. We want to start following the gravity turn. And this actually shows us, we may have already passed max Q. Well, not quite, but it's trying real hard. I didn't realize how slow this rocket was. Yeah, we're past max Q and we haven't even switched to the to the gravity turn yet. Oh, actually, we should have switched to the gravity turn. Yep, heading stable, blah, 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 blah. All right, so we are in a gravity turn now. Yeah, but a 500 is too fast, right? 500 is... Now our velocity vector is too close to our actual, and we're not... We should see our pitch is... still going down? Yeah. So you can see where we pitched over, where we corrected, and where we're following it over now as we go. So it is still dropping. But yeah, we want to, you know, probably sometime around here, like 100 meters a second might be better. Because we're going to be way overlofted. Yeah. I'm just going to set the velocity magnitude to like 100 instead of 500. And we're just going to try again and see if that is a better threshold for this design. Nothing else has changed. We just are going to start following, we're going to start tracking prograde a little bit sooner. And we should see that we've got this fixed pitch now. Yep. And then we pitch over and we start tracking. And this might be a little too soon or a little too aggressive, but... this is like 2 degrees. Yeah. 2 degrees, and then following prograde after... and here we go. We can see we're following for most of our... yeah, 2 degrees, and starting to follow prograde after 100 meters a second. 150 might be the sweet spot. No, it can't. I mean, my epsilon is what? I mean, we're within 0.01 degrees. I mean, assuming we trust the pitch error and yaw error coming from the steering manager, but still, I mean, this is pretty good, actually. What's our apoapsis? 100. Might come in a little bit low, but... And this is using no target. How far off it's heading? It's actually on heading. Its target heading is 355, not 360 exactly. Because you end up with weird behaviors around polar orbits actually ending up where you want them to be. If I look at the orbit info, inclination at 355 is a 91 degree inclination. So yeah, you gotta aim slightly retrograde if you actually want to hit the 90 degree inclination, because don't forget you already have your that eastward spin of the Earth's surface that is normally to your advantage. You actually have to counteract that when you want to end up in a 90 degree orbit. So the real problem with this is that, yes, it's working, but it's not figuring out, like, it's doing a gravity turn all the way up, which means that we have to trial and error the initial parameters. Which is fine, right? Like, if we just have to play with the pitch a little bit to dial in instead of specifying a target AP, I'd like to be able to just specify the target apoapsis. But maybe that's just not going to happen on the redstone, and that's an Atlas thing. Once I have the tech nodes for lunar whatever available, my next boosters, I can rely on that in their code. And maybe this is just going to be a big dumb rocket, because it's a redstone, and the redstone is a big dumb rocket. Oh, so this should be orienting itself. Did it? Orienting for circularization. Yeah, it did. Yeah, because now it's just tracking like a degree below prograde, and RCS is on. Cool. All right, so this is going to fire itself. The AP is a little lower than I would have liked. So I'm going to have to double check the contract requirements for the polar orbit. Oh, actually, I can do that right here. I have the contract. Oh, it doesn't care. Okay. It just has to be a stable orbit and have the right inclination. Cool. Well, I don't know if this launch script is better than the old one or not. It's definitely differenter. I mean, it's nice to have like a proper gravity turn script and to be able to like dial in the gravity turn parameters. .7 by 177. That is a stable orbit. Woohoo! Yeah, the gravity turn should be more efficient, because our old flight profile was pretty much always had a pretty significant AOA. And on this design, that's not hugely significant because our thrust is whatever. But cool. So I want to tweak this. I want to make sure that I can actually get all the science from this, because somehow I didn't get the science when I ran it the first time. And I think I mean, we have 4 hours battery, which should be plenty of time to run the experiment. Yeah, hour and a half. But I think I didn't fix, because I've been copying and pasting this avionics core since, like, my very first Araby, and I think it's still got the crappy, what am I trying to say? Comms. It doesn't have the comms range, so it times out and can't transmit the science. I think is what happened. So I need to fix that in the VAB. Well, I was hoping I would get around to designing my Atlas today, but we're already 2.5 hours in. But we have a gravity turn script. We have a cleaner design for our, like, explorer separation from the redstone, so I think I want to kind of finish out the, like, easy... It should just transmit on the next pass, but, like, Kerbalism is funky about how it works in Time Warp and stuff like that, so I just want to fix this a little bit and make sure that the comms is set up well. Comms... Oh no, this is like a default UHF band. This should be fine. Yeah, DSN. Plan. 1,000 kilometers. Yeah, we have full whatever. Cool. Yeah, so this should work. I think I just have to babysit the Kerbalism to get all the science transmitted. I think in the past I've gotten away with, like, leaving the scene and having Kerbalism transmit in the background. So I must have done something funky, or maybe Time Warp was fast enough that, like, Kerbalism was like, one frame this thing had battery, and then the next frame the battery was gone, and so it didn't transmit the science that had been accumulated in between. I think stuff like that can happen with Kerbalism. It doesn't, like, figure out, like, oh, how much of this could have happened, like, partway through a frame. It just kind of integrates it. Tartarus, welcome, welcome! Cool, so this should be good for polar orbit then, right? Is there anything that I am missing before I hit the big green button and launch this thing? Yes, there actually is. I want to double check. Awesome. I'm glad you made it in. I mean, is a YouTube bod sort of like having a face for radio? Is that the same? What do I... Yeah, 58 solids I don't have yet. So we are not gonna upgrade the baby sergeants. But we also get, when we grab this tech, we're gonna get the Castor 1. And I think strapping some side boosters onto my redstone, which is completely ahistoric, but will be hilarious, should help a lot with our initial launch profile, because right now we are heaving off of the launch pad. And a little bit more TWR early on should help a lot with gravity losses, as well as with sort of getting initial aerodynamic stability for the gravity turn. So one might... Yeah, it is the Kerbal way, and it is the law, but in this case, I think more boosters is actually helpful. The question is, will I have any flights to do with those boosters before I build my Atlas? And then... I think that was the only thing I wanted to double check, that I had didn't have this upgrade available. Otherwise, we're pretty much, I mean, I'm out of science, so I have to get this thing running so I can grab satellite era science and start getting more science. Looking at our available missions, we're doing polar, and this has very few specific requirements, so I think it should be fine with the current script. Solar powered also... Solar powered wants a higher periapsis, so we're going to have to tweak our initial pitch angle and some things like that. But I think other than that, we'll be okay. Just strapping some solar panels onto the sides of the existing thing and flinging it into space. And then scientific has a little more specific requirements. to emulate a proper Explorer 1 launch. And possibly by the time I push this out, we might have... We probably won't have the 1958 solids, just because my science is so tight right now. I mean, maybe. If I start running the early television camera, not a huge amount of science, but just throw an early TV camera onto our... If I do an intermediate launch... Oh, primitive solar panels is its own. I thought it was... Okay, it is. We do get tiny solar panels in the satellite era electronics tech, sort of at the base. These 1956 tech solar panels. So that's fine. So yeah, we'll be able to slap some solar panels on. And then once we get the satellite era science, we can always throw a couple of satellites up, right? We have to do the cosmic ray science, the Geiger-Müller counter, for the scientific satellite contract. But if we're having issues... This one's not too heavy, is it? One of these is really heavy. Magnetometer boom is, yeah, several times heavier. Like 30 times heavier than the Geiger-Müller counter. Film camera is a whole different thing to figure out. For these more advanced film cameras, we're really looking at needing to do sample return capsules because they need a long enough time that a suborbital trajectory isn't good enough. Okay, cool. Let's get our polar satellite launched, and let's at least get the science we can get from that. And then hopefully we can do solar-powered satellite pretty quickly, and then we just have to get the tech unlock for the first scientific satellite. Yeah. Let's launch. Acknowledged. Oh. Unlock one part. Yes. Okay. Oh, whoops. I just realized that I didn't fix my overlay, and it still has my Factorio text on it. There is no factory to add people's names to in the KSP. Oh, well. All right. Orbiter 2. Rollout. But please do not transform. I like my rockets to stay in the shape I built them. All right, hopefully, fingers are crossing all my fingers and toes here. But hopefully this does what it's supposed to do. I didn't add the countdown back in, so gotta remember to do that for future launches. So yeah, we tilt over whatever that is, the 2 degrees. Then we wait for velocity. And we're about to find out how reproducible this is. I probably should have ran it like 2 or 3 times in the sim before I did it, instead of just one. There we go. Heading stable, switching to gravity turn. Oh, the other thing I didn't double check in the sim. I didn't double check that the overall orbital inclination was correct if we didn't end up at like a 96 or an 84 or something. But hopefully it's right. Oh, no, it was right. It was right, because we were getting the countdown on stable orbit in the contract, so I think we were okay. I might do a little bit of research to try to be able to figure out the, some of the orbital parameters and be able to say, like, what do we expect our prograde vector at periapsis to be? But I think I'm going to have to learn a lot about the KSP internals to make that work. All right, right around 200 kilometer AP. This is about what we got in the sim, right? So I think this will be a fine launch. What's our inclination is 93. We hit 91 in the sim. That has me a little worried. 93 is... Yeah, it's just a lot of math. It's a lot of math. I mean, if you want to figure out, like, the starting parameters for, like, a full gravity turn to your orbital insertion burn, like we're doing here, where your PE is whatever it burns out at, that's harder. But if you're willing to overloft slightly and then correct, and yes, you will burn a little bit of extra fuel that way, you know, you just kind of want to get yourself in the general direction of the right shape, and then once you're in space, it's just standard orbital maneuvering to push your AP and PE around. Orienting for circularization. Beautiful. Beautiful, beautiful, beautiful. How are we on this contract? Let's see if we keep this inclination. I'm worried about this 93 degrees. And pretty much every profile that you see these days with modern rockets is slightly overlofted and then you correct. And I'm not sure why that is entirely, but it is a thing. technically this is a slightly overlofted profile too, because we are burning, I think 1 degree below prograde is our burn target for this profile. So we're going to bring our AP down just that teeniest bit. Okay, our inclination is going down, not up, so I think we're going to be okay with our final orbit as long as we hit... Oh no, our AP is going up! That's interesting. I was expecting us to be slightly under. Well, doesn't matter. We're in an orbit. It's not a beautiful orbit, but it's an orbit. So let's look at this data, and I am just going to hit some time warp. A little faster than that. Turn off the flight recorder. We are very dark. Here, let's get back around to the light side of the planet so we can see what we're doing. See if we can get a connection again. Because we are pretty high up. We're at that, like, 1.5 megameters, which is probably out of range. Yep, I'm just going to babysit this and make sure we get the science. Oh, is that Antarctica? Hello, Antarctica. Yeah, we're over the oceans. Here we go. Yeah, dumping a bunch of data. And, oh, we're done. We're done. Cool. That's it. We just have to wait for this to finish dumping the data. Contract is complete. Contract is complete. Oof. All right. I think we're done with this ship then. Ship. It's not a ship. There's no one in it. But I think we are done with this probe. All right, so for our next one, we're just waiting for a tech increase. We're waiting to get this satellite era electronics. And then we also need to grab satellite era science. And hopefully, fingers crossed, we can manage without needing this baby sergeant upgrade. Hopefully we can get at least some science out of something. I need like 2.5 science if I need to enqueue this. No, just 1.5 science. Okay. So if I do end up needing this before I can get a proper Explorer 1 profile, I can get 1.5 science with this stuff that's available to me. Again, I can put a rocket on a polar orbit with a TV camera and just like get a ton of easy early science. But for now, I think what we're waiting for is the electronics research so that we can get solar panels for the solar satellite. Oh, sun synchronous orbit. Here we go. This is hard with solids. With a low eccentricity like this. Should give money, not science. Yeah. Alas. Let's see if we can hit that. I mean, the problem is going to be the solids. I don't think we could have the, yeah, I just still don't think we have enough, the fine-grained enough control, even reading the eccentricity. But we have to push the periapsis up higher. And like an eccentricity of 0.04 is fairly circular. What is... What does that number actually mean? Like... Yeah, it's pretty close to circular. What I do think I want to do is start designing, because I want to see if I can achieve it without the 1958 solids tech. Let's see if we can do a proper Explorer 1 with the right periaps and apoaps for the first scientific satellite. Because now that I have the research going, I have all the prototype parts, and I can do that. And then I'll do sun synchronous another time. Plus, it's optional. Look, I think I just need to get solar powered and scientific, and then we're done. Atmosphere analysis as well. Okay. Have to figure out what that one is, but I think I have all the abilities to do that pretty easily. Atmosphere analysis wants what? Oh, solar powered. Okay. PE above 325, AP above 680. Run, temperature, and PE between 200 and 900, AP above 1500, have to transmit a day's worth of cosmic ray science, so we want it to be solar powered, because we don't want to carry a day of batteries. Not that this one needs to be solar powered. But I think I can do this one. As long as I get the first solar powered first, can I run this one at the same time that I do for scientific? I don't think they have any conflicting requirements. Does a growing potato battery count as solar power? Can you use a potato as a battery while it's growing? I have questions about how the electrochemical reactions affect the life cycle of the potato. Okay. What am I doing with this that is different? I am changing its science payload. We need thermometer and thermometer and barometer. Oh, can I not use experimental in this view? That's annoying. Because, like, I have the experimental part, right? If I go to science, wherever it is. Yeah, I have the Geiger-Müller. .0022 Okay, so this is lighter than the mass ion spectrometer. So keeping the spectrometer on, I think, is roughly equivalent. power requirements are probably different, but 100 milliwatts versus 2 watts. Oh, the Geiger-Miller counter is free, is what I'm seeing. It's very light. This is easy. Cool. In that case, all we need to do is find tiny solar panels. These are the statics? Ooh, those are huge. Are these procedural, though? Yes, okay. Yeah, a Geiger counter is a very simple device. It's just funny that, like, we have a mass ion spectrometer that we can send up before the Geiger counter. But I guess it is just a vacuum tube, so... I mean, that should be plenty of power. Right. Electric charge. Duration only 6 hours. Consumed 31, produced 8. Oh, because I didn't fix my antenna. I just said, lol, yeah, we can use the big one. It'll be fine. DSN tracking station at 1,500 kilometers plan. How low can you go? 6 dB. So that should fix some of our power consumption. 31 watts. What's using all that power? Oh, is it a gas tube, not a vacuum tube? I don't know. I believe you. Output at PE 12.38 watts. Why do you say only produced 8? Is this a Kerbalism thing? Oh, doesn't Kerbalism do a weird thing where, like, it only sees the sun that you get into this room? Like, it thinks things are shadowed? I feel like this is a thing. How do I fix that? I'm going to figure out how to fix that and figure out how to get Kerbalism to tell me how much power I actually have. And Twitch is about actually to switch to an ad break. So I'm going to get myself some more water and stretch my legs, and then we will figure out Kerbalism and power. All right. As if I really know when the ad break is going to start. Twitch gives me a second-by-second countdown, and then the countdown hits 0, and then it waits between 30 seconds and a minute before it tells me that ads are actually running, so I have no idea if they're actually running during that period of time or not. Starting soon is what it says. It hit 0, and now it says starting soon. I'm sure there's some stream delay accounted for in how they do it, but... Alright, I'm gonna step away and get some more water. I will return in a couple minutes. Okay, I'm back. Just in time for the ad to be over. Yay. At least as in time for what Twitch tells me is the ad being over. Oh, you didn't get it. Woohoo! Congratulations. That's so weird. But, I won't complain about people not having to see ads. Okay. So the question is... consumed 31 watts, produced 8 watts. Why so much power usage? I mean, yeah, the mass spectrometer pulls a little bit. Oh, this probably also assumes we're, like, broadcasting the whole time, which we won't be. Oh, no. Okay, yeah, active transmission time is fine. Is it just the avionics in general are that hungry still? 25 watts. Yeah, okay. Oh yeah, and then the next stage is 150 milliwatts. Okay, so that's the issue. Let me double check then the requirements. Leave the 5090 on the ground. Yeah. So First Scientific needs 1 day's worth of cosmic ray science. Okay. So we do have to be, like, power positive. Ew. Same thing with first solar-powered satellite, is we need positive energy balance. And I'm looking at my solar panel tech, and I'm saying... I'm not happy with that. Do I have to grab this early avionics node too? Shoot. Alright, I am gonna have to get some more science then. We just have to. Let's figure out what I can do to get some more science. I don't want to start flying planes. I know I talked about it as an option last time. I don't like planes. So pressure scan. Flying high in space lower, done. Temperature scan. Flying high is per biome. Mass spectrometry. Oh, still is not done flying high at all. Oh, because it takes like 2 hours to run. What am I looking at? 2 hours should be doable with batteries? Yeah. But the issue is it's 2 hours in the atmosphere. I've already finished it in space. This is the one that I just made sure to finish in space in the last mission. Biosample. Flying high is done. Space low is not. Okay. Biosample 2 is just forever. It's a 1-day duration. Can I do a suborbital launch on my redstone with, like, a biosample and a camera and launch it at a weird angle? Let's put together a real stupid rocket. That's... Let's see how silly we can get. Start with the Orbiter 2. Yeah, it's just a matter of can we spend enough time in space low in the right biomes for the camera to and the biosample to do their thing. But basically, we take open U, pull that off, take all of this off, and then throw in a basic biosample and a camera. Biosample 2, I'm going to put on a satellite because, again, it's got like a day to run. But sample 1 only has 20 minutes. I mean, we can get a few minutes on a suborbital, right? If we do a couple of launches. That's quite a bit of science available to us. Oh, there's only 10 minutes of it left because we're half done. And then... what was I saying? Photography? Yeah, space low is per biome. And I've only ever launched over water. Okay. So if I take this thing with the biosample and a film camera and launch it suborbital, like along the trajectory I was doing for polar launches, this should bring back at least ones of science, maybe even more than 10. The question is, can we get it reliable enough? All right, so this thing, first of all, the top needs to be 1.25. And then I want to put in a... what am I doing with this? I want a parachute. And I want a... do I want to try to put this all in a shroud? I should put it in a shroud. Does it matter? Do I care? Because if I just take this, parachute editor, size is fine, you're a main, single shoot, whatever. This is a double, so let me get through all this. It's been a little bit since I did a parachute. 0 spares, wanted touchdown speed of 10 with 2 parachutes. Our pre-deployment altitude is 1,000. Actually, no. I'm actually going to do this right. I'm going to do one of these as a drogue shoot. As a drogue, wanted speed at target altitude 80 by 700. We deploy at 2,500, that's fine. And then you pre-deploy at 1,000 and fully deploy at 700. Okay. Make sure that this is set to 1 shoot for the main. Yeah. I don't know. That looks vaguely correct. And then, what are you? All right. Let's get the script for this thing written. It shouldn't be too bad. Well, because it's going to be this, right? except we basically do this. Let me save this as something new. New CurveScript file. Science. Okay. All of this goes away, and it's just like wait until ship, whatever vertical speed is. Vertical speed. And then we stage the parachutes. That's easy. Okay. And then our staging... Oh, we don't need the separators on this at all. So our staging is just this. We launch, we follow the suborbital trajectory, and then we dump our science all over the ground. I could have chosen a million better ways to say that, but those are the words that came out of my face. All right, this should work. Let's sim this. Let's see what it can do. Oh, I probably forgot to start the science on those things. Let me remember to do that. Oh, and I didn't set the right boot script, so this is just wrong entirely anyway. Ugh. Okay, let's try again with the right boot script. Science. Let's enable. This is launching, yeah, into that like 355 degree whatever. So we're basically going to launch a silence payload towards the Arctic, question mark? And how much science do I have at the start of this? That is important to know. I can't see it from here. I'll see it when we get into the flight scene. Oh, I might also be able to throw the like 50 units of sounding payload on this and hit 6 megameters and get a little bit of So we start out with 4.5 science. Info, data, can I see auto? Waiting. Yeah. I mean, obviously this is ridiculous without some sort of shroud at the top, but the amount that I care is very, very low right now. I might have a 1.25 meter science core tooled, so I might be able to switch to that and do something different with just a shroud around the biosample. But see how far we get. What's our current situation science-wise? How do I see that? I'm not sure if I can. There we go. Okay. Yep. And now we're running... Yeah, we have a bunch of planetary photography to run. Oh, we even have some temperature scans to run in upper atmosphere and some of these other regions. Cool. Yeah, there we go. Earth flying low, 0.2 credits. I might want to tilt this a little lower. I'm not sure how I feel about that 320 AP with a re-entry. We'll see. This is a lot of rocket to try to send suborbital. But we are sending our... Where are we going? What does America look like? Where am I? Gulf of Mexico. I'm trying to see where we're landing, and I really can't quite tell. I'm trying to, like, see if I can recognize the Great Lakes or anything. I'm not quite sure where the coast of, like, Maine is. But I want to say we're, like, solidly in Canada. And yeah, biological samples running. That'll run for several minutes in space. Planetary photography's running. Plus, we've already transmitted 0.2. Okay. I should be able to see it from here. Can I see what I've collected? Yeah, flight plus 1.2. Biological plus some of this stuff. Plus even some temperature scan, apparently. Hopefully, because we're coming in at a pretty shallow angle, we're going to do okay. But we will find out shortly. Nope, not even close to okay. Yeah, that's what I was afraid of. We're just going too fast with this ship. So how do I achieve what I want here? I mean, obviously I could use a smaller redstone. That's an option. You know, I can look at the original orbiter with its shittier booster. Where's Science McScience Face? I didn't mean to load the other one. I meant to merge the other one. Thank you. Take it off from, like, here. And then the other thing that I might be able to do is if I make a... Let's reconfigure this avionics. A cylinder at 1.25. And That should... I mean, let me check this. RP-1, avionics, S2... 1.25 by 0.1. Okay. So this might already be tooled. And then we put on top of this, payload. We drop in, and it doesn't really matter which one. Truss adapter, base size of 1.25. This goes on top. Bearings go on top of that. We turn off the fairing decoupler because we're never going to decouple them. So, what is this? Oh, I also need to turn off the decoupler on this. Can I turn off this decoupler? Yes. Because these, I think I can increase the density on. I don't know what that does. Like, does the density affect the temperature? Let's find out. GitHub.com, KSPRO slash... Is it in RO tanks? No. Procedural fairings. Cool. And I know you guys can't see this. I don't have my main browser hooked up to my OBS, so there is no way for me to share this without changing some things. But what I want to see is if density affects the temperature. Bearing base. Density, 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 density. Set density field. No, that's fine. Apply. Yeah, so where is this actually used? On start, blah, 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 blah. Update part parameters. Fairing mass equals volume times density. Braking force is total mass times specific braking force. What is that? Temperature? Do we have temperature in the code at all? No. What about the word heat? Only as a subset of the word cheat. So no. So I'm gonna guess not. That's too bad. But at least this will, like, try to protect the... I wonder if I could also just, like, deploy my drogue chute super early. Like... Right now, my pre-deployment altitude is 30,000. I'll have to see when we're burning up, but... Yeah, maybe that is also something to try, is to deploy the drogue earlier so that it can start to slow us down as we enter the atmosphere. But I'm going to sim this just with these fairings on top. I'm going to see if this helps. I don't think it'll matter that much, but we're a better looking rocket at least. Oh, excessive amounts of... Yep, that's because... Oh, and the other thing I can be doing on this is I can add the, remove nitrogen. This is a high-pressure tank, right? Yeah, sounding payload. What do I need for that? Is it 50 for the 60,000 downrange? Let me double-check that. I'm not sure if this rocket in this configuration can hit that downrange, but we may as well try. The goal is science, but if I can hit the downrange milestone... sounding payload of 50 units, downrange of 6,000. And then the other one is sounding payload of... I think it's the same sounding payload, but 7,500 kilometers. But I'm launching, like, in the wrong direction, and we'll see if our downrange number works out. Okay. Think this is ready. Procedural tank. Tank UI. Did I not save my sounding payload? I did. Okay. Yeah, let's sim this with the smaller rocket. I don't know how much the fairing is going to help. Woohoo! Turns out, this program is not written for this booster. So I suspect we are going to just burn up. Oh! Well, yes. But... that's not what I meant to do. I hope that button works right with simulations. Oh. Okay. So two things. One, trying to do this with this booster was silly. We're not doing it. We're gonna grab to Orbiter 2. We're gonna figure this out. Did I not just... I didn't hit merge again. Didn't hit merge again. Where is Science McScience Face? Merge. Okay. So what we're gonna do is we're gonna set this pre-deployment to like stupid high altitude. We're gonna set this to like 80,000. Then, I mean, really what I want is a heat shield. But I don't have one yet, so... I don't want to have to design a smaller rocket. I don't want to have to unlock any parts for it. I really just want to, like, get the science that I can get from this. Nope. I tried to speed up too soon, and I broke KOS. Gotta wait until it's off the launch pad before I accelerate. I think what happens is when you're in, even when you're in physics warp, it, like, messes up the propellant loading or whatever, and things get confused. Oh, I have the wrong avionics. Whoops. I was trying to be clever and not have to redo the sounding payload, but this avionics is wrong. Let me fix that. What's the one that I have tooled? Near Earth 1, 34.9 tons, 1.875 by 0.31. All right. I think I probably just came upon that by going to configure, setting this to 35 tons, hitting apply. Oh, look at that. The length is 0.31 and we're 34.9 tons. All right. As long as we have our, yeah, we have these fairings that I haven't tooled. But everything else says it's tooled. The payload is right here. Volume available, 179 out of 229. Yep, because we're using 50 on the doodly-doos. All right, let's try this again. The other thing I can try to do is pitch over just a little bit more. Because, like, this is supposed to be a suborbital flight anyway. And if we spend more time in the atmosphere, we're going to have more friction, more air resistance early on. And we won't be coming in as fast. Because, yeah, what's our AP on this? 370? That's high. That's high for a suborbital flight. So I can tweak the flight profile a little bit. All right, I think I set this to deploy at like 80. And it broke. Oh. That capsule survived. Wait, the fairings survive. The fairings survive. Okay. Okay. We can make this work. We can totally make this work. It's going to be stupid, but it'll work. And if it works, then it's not stupid. Okay. So you are going to have a top of... Why is the base 1.89 when everything else is 1.875? Has this always been wrong? 1.875. That's fine. So this comes off of here. At the top, science comes off, doesn't matter. This comes off, doesn't matter. Science connects to the bottom. This gets a diameter of 1.875 now. Connects here. Connects there. That piece. And this piece. Okay. So now we're coming in fared. And we do have to make some tweaks to the flight profile for that. Mainly, I do need this to decouple. And I do need the fairings to decouple. Because the parachute is, like, inside the fairings. So after launch, we want to drop the payload. That's what we're currently doing. And then once we're through atmosphere, we want to drop the fairings and decouple the base. And then deploy... Okay. So this parachute at our pre-deployment altitude of 80,000. Let's go back to 30,000. Fly a couple of times just because stuff changes. And then let's update the code. So we wait until the vertical speed is less than 0 and we drop the payload. Then we wait until ship altitude is less than, I don't know, 50 kilometers. And we do the rest. Yeah. Because that'll open the fairing, drop the whatevers, and then it'll pre-deploy the parachute, but the parachute won't actually fire yet. This can all be one stage. Because the parachutes won't try to deploy until they hit their deployment altitude. So that's what we want. And then I can set the density on this fairing to be, in theory, more protective. I don't know. We'll see if it's necessary. But last time, the fairing survived. So I'm going to try this. The question is, does the camera work when it's occluded? Does the game know? Does the game know that the camera is occluded? I'm going to have to check that. Worst case, I might not be able to take the camera along and we only get the bioscience, but I'd like to take the camera along. Oh, yep. Mass spectrometry shrouded. Planetary photography shrouded. Okay. That's too bad. So all we're going to get is the biological sample and a little bit of temperature when we're back in the atmosphere. So that defeats the purpose of this flight. We're not getting the things that need to run running. Oh! They run up here, though. This is unshrouded now. Okay. So maybe I just need to pop this open at the start, because then the camera won't be considered shrouded. I'm willing to cheese it a little bit. problem is, are we going to get re-entry the right way or the wrong way? Okay, well, 50 is too high because I just blew up my biopod, but I think we're okay. I think we're okay. We can fix a couple things. And it's all code changes. I love it when things are code changes and not ship changes. 1, ship altitude down to like 35. And if I need to go lower than that, then I need to fix my... Whoops, I reverted to launch, not to pause. And the other thing I just want to do is there's no reason to wait. We can just stage as soon as the redstone is done. And then we wait until we're lower and we stage again. Man, if I can get a couple dozen science out of this, I will be super happy. Even just a dozen would be enough to get me everything I need, I think, for my next couple of launches. Oh, and I should also keep an eye on the downrange and see how close to that 6 megameters we're getting. Because if we're nowhere close, well, it doesn't really matter. Yeah, everything's going to be shrouded on ascent. There's nothing I can do about that. But now it's running, and we're still in atmosphere high, so we're getting some of the time that we need in these different biomes. Beautiful. This is what I want to see. And then, yeah, biosample is going to run its last 10 minutes, which is like 10 science. Bunch of planetary photography. And then on re-entry, we'll keep running mass spectrometry in the atmosphere. We're never going to finish that. It's fine. It takes like 2 hours of time spent in atmosphere high, and I just don't have the patience to do that many flights. But if I look at data, we've got, what, 4.6 credits of Earth Space Low Science from the biosample. 0.2, yeah, small amounts of most other things. Ooh, like 2 credits on some of the photography ones? That is not bad. So I think I'm going to have to run this, like, fly this, like, twice. What's our downrange, by the way? Only, like, 1 megameter. Okay, so this isn't going to get us the new downrange contracts. That's okay. Oh, and we're getting temperature scan in a new biome. I should probably point this more retrograde so we cover more biomes flying across the US. Right now, we're just kind of going northish. But I guess I'm running it twice anyway, so. So the question is, will this survive? Oh, look at that. That deployment is like perfect at 35. Maybe 31 would be better. And then the drogue should pre-deploy. And we're going to start slowing down. Yep. And let's just physics warp. I mean, this should be a fine recovery at this point. We only transmitted like 0.2, but that's fine. We expect most of the science to be on the ship. Yeah, plus 4.6 bio. And planetary photography is plus 2.8. So that's a net of 6 and change science from one flight. Nice. I do think I want to aim it more inland so that we get the space low photography over different biomes. But cool. Revert to vehicle assembly. So I'm going to launch a couple of these at just different directions. I'm gonna tilt this in instead of 5 degrees off of north. Let's do more like 45 degrees off of north. So like a 315. And we're gonna launch a couple of these, and I'll just change the if I'm going to launch more than one of these, I probably do want to tool those fairings. They're not that expensive. They are that expensive. Procedural fairing, 1.875. But why are you so expensive? Oh, because you have decouplers. That's why, right? If I turn off the decoupler, you're like 200? Yeah. Can I make these cheaper by changing the injection power? No. All right. Well... that just is what it is, unfortunately. But I can launch 2 of these. And then after the first one flies, I'll point the second one at, like, a different trajectory, just to try to get some different biomes. And that should, hopefully give us all the science we need for... our next couple of missions, getting the solar power satellite to work and getting the... because I'm going to need electronic after satellite era science. I'm going to need the, let me see here. Early avionics and probes, which is 7 science, so that's 2.4 more. And ideally 58 solid rockets, especially if I'm going to try to be achieving multiple goals with one satellite. So that's another 6 on top of that. So I need like 9 science. 10 science would be plenty. You know, if I can get primitive solar panels, then like... this is a better tech level, which will improve my solar panels. And then lunar range communication, which will let me upgrade the tracking station. And then I can finally use maneuver nodes. To be clear, this only unlocks the ability to do these upgrades. I do not actually get... oh, and we also have early EDL, which I'm going to need for, again, more of this science. Once we finish satellites... we're going to be running these early Earth observation satellites, these early commercial applications, maybe grab early lunar probes and start working towards that because it's worth a lot of money. But like getting through these commercial ones will give us a bunch of money. And the goal is to build a workhorse launcher that we can just like be blasting all these telecommunications contracts out, things like that. Be maintained forever. What does that mean? If I go to like communications network, early communications network. No, commercial applications. Telecommunications level 1. Unknown parameter. Okay. That's not helpful. Well. That seems bad and potentially broken. I'm going to have to check with the Discord and see if I need to update a mod. But we've got 2 of these Science McScience Face probes ready to go. Yeah, what I was saying was we're going to end up doing these commercial applications, but like while these are running, we're going to need to be getting science to get ourselves up to lunar, and then we'll get a ton of science from the moon. But like running the advanced biological pod, which takes like a day in space, so that really needs to be an orbit, right? So we're going to have to be starting to work on, while we're making money from other stuff, we're going to have to start running more of these scientific missions just on our own time, even when they don't complete contracts. You know, getting improved film cameras, all of these things. Ooh. Ah. RTGs. But we're not getting there today. I'd really like to get solar, scientific, and whatever the last one is done. Today before I call it a day. This has taken much longer than I had necessarily anticipated. All right, there's satellite era electronics. I don't think this gives me anything super valuable right away. We do get the satellite buses that we need for the navigation contracts. And we do get our initial solar panels at the lowest tech level. I might skip tech level 0 and jump right into tech level 1 because we might get enough science to get it. But for our first solar-powered satellite, we need avionics and probes. If I cancel this one, can I start this one? Yes. Okay, cool. So I should be able to get first solar-powered ready to go, and I'm going to fly Science McScience Face first, and then I'll see about, with early avionics and probes, can I design a ship for solar-powered satellite? And then... what is... I always forget what the last one is. The atmospheric analysis satellite, right. And this one, despite requiring first solar, I don't see why we can't do this at the same time as first scientific, because I think their orbital parameters are compatible. The only issue is that first scientific, the science payload on it needs to be up in orbit for a day, which, yes, you can do with batteries, but why when you can do solar? So I want to get solar first. We'll get this requirement, and then I should be able to do atmospheric analysis and scientific, maybe on the same flight, but if not, back to back. And I've been talking to myself with the wrong screen on. That's okay. I have no idea when exactly I did that. let's see if this works as it is supposed to. I am just going to fast forward through this. I don't want to spend any more time on this launch than I have to. I really don't. So yeah, you can see this time we're pointed more inland, so I'm hopeful that we will avoid getting any science from the oceans biome where we already have it, and we should get a few more points from stuff up here. Twitch is going to run an ad, but we saw, well, maybe we didn't see this flight in the sim, but I don't know. This isn't an important mission, so I'm not really worried about if it ends up behind a Twitch ad. Ooh, that didn't go into space for very long. I don't love that. How much did we get for the biosample? Just 2 credits. Okay. So I might have to do that more northerly direction after all, just to get the biosample into space for longer, because that's a big chunk of the science that I'm going to retrieve from this. All right. Well, what did we end up with on here? Planetary photography, 2. Biosample, another 2, so that's 4. Okay. Well, that's enough to start one of the techs, and that's really all that matters. Is it enough to start one of the techs? How much science do I have? 4.6? Yeah, okay. So I can enable the, I'll grab the science tech again. We should be able to do solar now that we are in... Now that we have the better avionics. We can upgrade our avionics and do solar pretty easily. And then, oh, that's a cool screenshot. Is that the mun over there? No, that is the sun. We're just right on the edge of sunrise. All right. Done. Plenty of science. Okay. So now we can enable satellite era science. So let's build or upgrade our Orbiter 2 to a let's upgrade, sorry. Open Orbiter 2. And this is going to be the Orbiter 2S. because this is going to be the solar-powered one. So if we open the avionics, we should now be able to grab early. Yeah, we need early avionics and probes, which isn't quite researched yet, but will be soon. Right? If I check management. Yeah, it's our next tech. Cool. And with early avionics and probes, we can keep much smaller batteries on here too. Like, this thing's going to be wild, what you will see this thing doing now. Yeah, so duration 4 hours with only 100 kilojoules. Our consumption is now 6.25 watts. So running this thing off of solar, even tier 0 solar, is not a problem at all. Kind of want to do hexagons because they are the bestagons. And then this says, this does not say perpetual. Why? Consumed, produced none? What do you mean produced none? Earth. Yeah, simulated solar panel output. But why? Why do you hate me? Okay, well that's wrong, but output 9, yeah, each of these is like 10 watts, and this whole thing only pulls 6.25. So this should be fine. I'm not sure why this hasn't figured itself out yet. Oh, in sunlight. There we go. This still can't figure itself out. I don't know. I'm just going to run a sim. As far as our flight profile for this, we're going to go at our 90 degrees instead of 355. And we're going to have to tweak probably this velocity surface magnitude here a little bit. Sort of how fast are we going when we initiate our gravity turn? And I'm gonna switch this into a parameter, actually. Heading gravity turn velocity. Cool. And that should give us what we want there. And we're going to start with 100. We'll figure out what that looks like. And then I think the rest of it, the circularization, firing the upper stage, all that is fine. We just have to make sure that our orbital parameters are good for both. I mean, ideally... Well, this one only has to do first solar. It would be nice to also do first scientific if I can hit the orbit. Well, here we go. Now it says it's producing 10 kilowatts. None. 10 kilowatts. I don't think these solar panels are being simulated correctly. That's what I think. Whoops. All right, so this is an Orbiter 2 Solar. Flight profile should be, I mean, the same. Yeah, let's sim it. All right. And this doesn't have the right silence payload on it, but I think it should at least be power positive once it's in space. At least for part of its flight. Oh, well, that's just very, very not what we want. Let's change our pitch. Maybe? It did seem like it was doing some weird stuff with how it was trying to orient itself at launch, so... Let's keep an eye on that and try to understand what it's doing, but I've pitched it over an extra degree, so hopefully it can figure itself out. I mean, that looks fine. Pitches over, and then it'll wait until it hits did I say 100? 100, yeah, I haven't changed that. Oh, because it's trying to do this roll maneuver. So we don't ever think we're stable. Yep, there we go. So we're going almost 300. Okay, understood. So this is that third parameter to heading that I'm always, like, ignoring. Let's see if we can figure out how to make it work. Right, so we have a roll. It's optional. Okay, if I just ignore it, does it make it 0 or does it compute something meaningful? That's the interesting question. Because what I want is for it to stop doing this like 90-degree roll at launch. So I've changed the heading call to not provide that 0. We will see what it does. Are we still rolling? Yeah, we're still rolling. Okay. So I need to add that third parameter back, and I need to make it to like... Well, I mean, really I want it to be locked to like... heading? Do I just want my roll to always be the same? It's either going to be the same or it's going to be negative, right? Because like we're at 90 degrees. Yeah, we'll see. Whoops, didn't switch my screen. Here. These where it says heading in this third position used to be zeros. And that would force it to roll depending on which direction it was pitched in, so that like what it thought was the top of the rocket was always up. But I actually don't care what the top of the rocket is. I just want it to tilt. So I'm hopeful that this will null out my that roll. And if it's not rolling, then we should see our pitch and yaw stabilize better. Is this trying to do a full 180 now? Well, it's doing something differently. It's still doing weird stuff with roll. And we are pitching over way too hard now. Okay, that is... Okay, this is not right. Let's try negative. Let's see if that does what it needs to do. I'm not convinced that it will. This is just one of those things where I don't fully understand the spaces that we're working in and how the like heading call is calculated. Yeah, this looks right. This is just leaning over, it's not rolling. Perfect. That is what I want. And then we should hit 100 meters a second and go into our gravity turn program at that point. Boop. Yeah, and it pitches over hard. Okay, but this has the 3-degree pitch on it because I was trying to work around weird spin things. So I might need to tick the pitch back up a little more. I'm not sure why we're rolling still. That concerns me. Yeah, okay. Back to the code. Because we just locked the steering to prograde, so we should stop. I mean, I wonder if I want to do like a lock steering to, instead of heading, do I want to do like look dir up of the ship's surface prograde 4 vector, and then like ship, I mean, just up, right? I want the up vector of... Not convinced that is 100% what I want, but we'll try it. And then we're going to go back to this 2-degree pitch instead of 3. I don't really mind if it does a roll program. I just wanted to do it at a place where it's going to be safe and sane. So, like, if it starts trying to roll itself as it's doing its gravity turn, I think that's fine. The problem is when it tries to do it like during these initial pitch over maneuvers, that stuff gets weird. Alright, so we're gonna go up to 100. Oh, and we booped. Why did we boop? We booped because... used a direction in place of a vector. Oh, yep. Because prograde is a direction. Or sorry, up is a direction, which says pointing straight away. So I guess I also want that to be a 4 vector. Let's see if that works. Oh, and I like because I locked steering, even though the script broke, I think we're still in a gravity turn. Maybe not a great one. I'm just kind of tempted to see how this goes as it follows its prograde vector. Oh, we're tilted over way too far. Yeah. Okay. We're going to revert to launch, and we're going to see if I've got things a little more figured out. And then I guess I should resim the science ship as well, because I'm changing my library code. Yeah, because this does its little, like, barbecue roll to get itself facing up as it does the gravity turn. I kind of don't mind that. That's kind of a cool little flight trajectory. We're still coming in way too steep, so we do need to... Oh, maybe not. Yes, maybe yes. Okay. So let's just bump this up to like 150. Let's go a little more vertical. Still a lot of trial and error in all of these launch profiles. I'm starting to understand some of it better, but not as much as I would like, and certainly not enough that these are going to be nice and clean, unfortunately. So what waiting for 150 meters a second at 2 degrees means is that we'll end up more vertical, with more of our velocity vertical before we start following the gravity turn angle. Yeah. And 150 might be too high. We'll see what our AP ends up being at burnout. I think it needs to be between 700 and 900 for the $800. All right. I was going to say, I think it needs to be between 700 and 900 for our contract. And I'll double check the contract parameters. And again, if we can't quite hit them with this design, we'll hit them with the upgraded solids. It would be great if I could hit the parameters with this design, right? All right, and then, yep, orienting for deployment. Should open the terminal so we can actually see our debugging, but I don't think it matters at this point. Oh, I can't open the terminal. I don't have control. Ha! Well, this is where we hope that it figures itself out. There we go. Physics warp, not actual time warp. See if this can stabilize itself, although I messed it up hard by using the other time warp by accident. I think it'll be okay. It's not going to be perfect. All right, our time to apoapsis is increasing. Okay, so yeah, this can't quite hit with these engines the performance that we want. So let's try it with the other engines. Because for first solar, I don't think I have any AP requirements. I think I can just like have the rocket tilt down a little further and we'll be okay. It's just the 3X cluster. Switch to the new one. The 10X. Yeah, 11X cluster. Switch to the 3X cluster. Huh? 11X cluster. There we go. And the 1X. All right. So with the upgraded, and again, we can't fly this yet. We need that solid rocket engines, and we don't need it for first solar. We just need it for first scientific. And then our apoapsis is going to end up different because our mass is different a little bit with the different engines, although it should be pretty similar. Yeah, tilts over, does this little dance. All right, AP is similar. All right, and let's just physics warp through this part where it kind of aligns itself for deployment of the better rockets. And hopefully with the better engines, this thing's light enough now that it can hit its orbital goals. I mean, we can also tweak our orbital burn, because I think before I saw that we were coming in, we were pushing our AP forward still, and we really don't want to see that. We want to burn out with, like... Oh, shoot. I forgot to turn off physics warp. We're still pushing our apoapsis forward, which means we're a little bit pointed up of where we want to be. But we can fix that. That is really pretty simple to fix. All right, physics warp again through this part, and remember to turn the physics warp off when we get down to the actual part that we care about. Yeah, we're still pushing up the AP a little bit, and we don't need to be putting energy into our AP at all. Well, it's closer, but it's not right. I should be able to do this with this tech level. Like, this is an actual Explorer 1. So I think it's just a matter of tweaking the flight profile, maybe getting some weight out of the system where we don't need it a little bit. Like, how much delta V do I save if I, like, get rid of all of our... None. You know, if I cut this down to, like, a tenth of what it was, like 4,900 instead of 49,000, no. The answer is, doesn't matter. The nitrogen tank is not the problem. Let's double check the orbital parameters for First Scientific and for the other one again. Because we might be able to tweak our orbit just a little bit to nail where we want to be. So if we look early satellites, atmospheric analysis, AP above 600, PE above 255. Scientific wants, a PE between 200 and 900. Okay. So I can go for a lower AP. I only have to get up to like 300 instead of the 800 that we have right now. Okay. So let's do like a 120 meter a second instead of 150 and see if what our gravity turn looks like. Because yeah, if I can get to like that 250, 300 range and then have more of our velocity have been pointed towards boosting our, well, what is our PE initially, but turns into our AP. The other thing I might be able to do is, like, lighten this thing significantly, like... This claims 4 hours of battery life, but I don't think I actually need that much, although batteries are not as heavy as they used to be. You know, if I cut that in half... What are we looking at? Not a meaningful delta V increase. 1499 to, yeah, 1488. A few meters a second. I mean, across multiple stages, but... $10,482 to $10,4, yeah, 95. So just 13. Because for the other stages, it's mostly the pushing around the in-between stages. That's all the energy, right? It's not the... The other thing is trying to figure out if I can make the solar panels smaller, because it says our consumption is 6 watts, and each of these solar panels is 12. Oh, bringing these in is a noticeable improvement. Okay. So if I say I want, like, it to still be functional after a month, on a single panel, I want a single panel to be able to support the full ship after a month. Yep. So we can make these a lot smaller. Cool. That should save us a lot of... I mean, assuming my solar actually works, and I need to double check that. That should save us a lot of power. So let's resim this. Not a lot of power, a lot of fuel. Delta V. Let's see where our AP is with the 120 meter a second target for when we start to follow the gravity turn. So yeah, we pitch over, we gain our initial velocity, then we pitch over to the gravity turn position, start our roll. And then, let's see where our AP ends up. This is still going to be high. Not as high as it was. Well, yeah, not as high as it was. All right, let this get itself positioned. And again, I also need to tweak our burn time so that we're not pushing the AP forward as much. Oh, and I was looking at something else and forgot to stop fast forward before... Ugh. Okay. The brain cells are definitely starting to see that we are 5 hours into a stream, and it's getting a little... The focus is waning. But I do want to, excuse me, I do want to try to get these last couple orbits in and done. this session so that next time we can kind of dive into the next thing, right? And start working on bigger, better things. So it's just a matter of, did KSP just crash? Oh, dear. My save better not be corrupted. All right, well, while the game is loading, oh, there it goes. All right, patches applied from cache. That's a start, at least. I really, really hope we're gonna find something reasonable when we reload our save. Someone had fun with their space station design there. The USS Shran is blue. I like it. Good Enterprise reference. Always appreciate a good Enterprise reference. Okay, let's hope my save comes up at a reasonable time. I'm gonna have to check where we're at as far as research, and I'm gonna have to double check. The ships should be okay, right? Because the ship files are separate within the save compared to the persistent SFS file. All right, February 1958, one flight. So that is our polar satellite, I think, that's still up there. So we might be reasonably okay. I check contracts. There should be none active because I still haven't figured out if I'm going to do solar powered on its own yet. Well, I am. I'm just making sure that I can do scientific and that I've got the program right for it. Okay. All right, only minor panic there then. So atmospheric analysis, PE above. Oh, this one's a PE above 400. Okay, so I do have to hit this 400 kilometer PE if I want to try to meet both contact tracks at once. Scientific is, yeah. And then you're always hitting this AP requirement if you're hitting scientific. Okay. So I want like a 400 by 1500 orbit or higher. So let's open the 2S again. Did this get... No, this didn't get my updates to the solar panels. Okay, I don't think anyway. 6.25 watts, and these solar panels are generating 8.66 because I wanted to look at them in like 30 days. So yeah, this has like a month or so of wear and tear. Okay. So is this the right ship then? Is this all set to simulate? All right. I reverted for some reason, and that's why it crashed. And I already forgot why I reverted because I time warped too long. That's fine. Let's see where we can get to here. I already forget what the AP was. I think it was like 500 something, which is fine. We could try to bring it down a little bit, but I'm not too worried about it. 3, 4, 5. Yeah, it's a little high, but it'll do. And then time warp to... What I should really do is just add the, like, I can add the KOS code to turn off time warp. And even if I don't have it automatically start time warp, I can have it automatically stop time warp. So that when I'm doing silly things... All right, here we go. Whoa, 6,000 by 500. This is sufficient. This should achieve both the first scientific and the first atmospheric whatever contracts. Beautiful. But this is the version that has the uprated solids, so I want to get first solar done, and this is going to be the first 2SX is what I'm going to save this one as, and then I'm going to downrate the solids again, and we're going to run it one more time. Those uprated solids are huge. I didn't realize just how, like, impressive they were. But if we go back to the original solid config, and this will be the standard 2S. The 2SX has the better boosters. All right, and let's just sim this, and let's see what we end up with. Because that periapsis seemed, or sorry, apoapsis was huge compared to what I thought I was getting with these solids. Oh, but I also made the satellite lighter. So it's possible that this will achieve our goal without needing the 1958 solids tech, if we can hit because we have the lighter satellite now, right? Because I made the solar panels significantly smaller, and these early solars are heavy. So yeah. Our orbital burn should be pretty similar. Oh yeah, that's a lot less impressive. Then again... Nope, it's fine. Alright, so we don't need the uprated solids. Cool. This will do first solar, this will do first scientific, I think, and it should do also the other one. So the question is, do I run first solar now? Or do I... Chances that this crashes when I go to vehicle assembly building? Non-zero, unfortunately. Okay, we're good. Do I run it now, or do I wait until I have the science tech? Because, like... Oh, and I also still need the early avionics and probes. Okay. I mean, I could launch a couple more Science McScience Face. Rockets in the interim and just, like, catch up on this. When was Explorer 1 in the real world? That's the real question. January 31st, 1958. All right, I've already missed it. I beat Sputnik, but I'm way behind Explorer 1. And a lot of that has been research related. I did have some mistakes along the way, but research has been slowing me down a lot. How is my budget? Oh, I'm plus 18 even when I'm building Science McScience Face here, which is great, actually. Okay, I think I'm gonna wait till early avionics and probes. I'm gonna get the launch done there with first solar, and then I'll build another one for satellite era science and the final contract, I think is how I'm gonna do it. So let's just get those things done. We should have this all wrapped up in the next, I don't know, certainly within the next half an hour. All right, a nice afternoon launch for Science McScience Face. Oh, I want to change the launch azimuth, don't I? It's the last one I did at 355. Oh no, the last one I launched at a different launch azimuth. This one I did want to launch at 355. Okay, I already changed the script. Cool. Right, because previously we launched it more retrograde, and it didn't hit the altitude to collect as much of the science as we wanted. I remember how things work. So hopefully this time it will get itself into the right orientation. Yeah, that is a better AP. $30 and $40. All right. And now we just physics warp through this. And if we check the archive, we should see that we have... oh, no mass spectrometry. Oh, we'll get it on the way down. That's right. We should have a little biosample. Yeah, plus another 4.4. Oh, and there's still another flight's worth out there, it says. Photography, plus a few more. Okay, cool. I might run one more of these. It wouldn't hurt. Just to get the rest of the biosample 1 science and have a little more breathing room on my science than, although once I get the new tech, I want to be thinking about the entry, descent, and landing tech eventually too, and getting a sample return mission with either the advanced biopod or the next film camera as well. But yeah, once I have the science, I should be able to like throw a solar probe with a video camera into a polar orbit and just get like every biome and we want AGL, not ASL. Yeah, and we're good. Pop. All right, 7.1 science recovered. Excellent. Excellent. Yeah. And if we look in here, I'm actually not sure what the next thing I want is in that case, because, like, apparently we don't need this, although we might still want the caster as a booster engine. Pioneer adjustment motor is also good. If I'm going to try to do, like, a lunar anything, impactor or flyby with solids, upper stages, having more variety of solids will be good. But once we get into the 59 to 60, I think we start to get some good stuff. We have Algol. We have... Is this where I need to be for the Titan boosters? Is it 64 to 65 before I get them? Where? Yeah, here we go. No, that's for Saturn. Yeah, here we go. It's UI 1205. So that's the Titan. The Titan boosters that we get are a little further down the solids chain, 64 to 65. But getting the early castors and their upgrades will also be Castor 1 VAC versus Castor 1. Engine configs, yeah. Sea level and VAC. And then I think here we get new configs for the SL. That's a interesting way that these are handled for that. Not sure. At any rate, we should be able to hit first scientific satellite as soon as we get early avionics and probes. I wanted to launch one more Science McScience face. That's what I was saying. Because we still have a little more science to be gathered from it. So let's just launch it. Done. And every one of these launches that we do is also getting more DU for our engines, which is useful. Not that I think we're going to be using the NAA-75 itself for much longer, but I think it does transfer DU. Ooh, sunset launch? Let's do a sunset launch. Oh, and Twitch is just about to run an ad. I'm going to just let this run in the background while Twitch runs the ad, and I'm going to step away, and hopefully there isn't a failure. Yeah, enjoy the launch, YouTube and Twitch Turbo gang. Yeah. This is the first time I've actually seen that deployment not in fast forward. And it just occurred to me how this capsule's always picking up so much torque. It's the booster. I'm going to claim this is intentional. This is how we ensure that the camera that's pointed out the back can get sweeping panoramas by having the booster nudge the payload into this sort of tumbling orientation. All right, let's wrap this up. Let's get the science we need. Well, we actually don't need it at this point. Let's get the science we want, and then we can do our last couple of launches. Like I said, I think just solar powered. Which I can do as soon as I get the upgraded tech for the lower power solar panels. I guess I can grab the tech and grab the contract now and double check that the ship is actually going to pass. But I don't see why it wouldn't. All right, welcome back from the ads, for anyone who was watching ads. We're just waiting for this last science payload to come in. I think there's probably, I mean, technically a little bit left, but I'm not going to worry about that 0.7 science when we're going to have, 40 just from biological. More if I can get it into a space high orbit. I think similarly planetary photography. I could try to get more biomes, but do I care? Because we're gonna have the advanced photography soon. And I think the way it works is that when you have advanced versions of some things, they count for the basic one as well. But cool, yeah, 15 science. This is gonna be great. I'm not sure if I'm going to take 58 solids next or not. I probably want the better solar panels. And 58 orbital rocketry. This is the node for... What is in this one? I think we get the Aegina. Yeah, okay, we have the Aegina here. And early AJ-10s are extremely unreliable. There's a reason that I really didn't switch to this when I was doing some early tests, and I kept using the XASR because this engine sucks. But if I can use an Aegina, it will suck less. I'm not sure where or if I can get the Aegina bus, like the satellite bus for an Aegina. Thought that was around somewhere. But maybe I am mistaken. I might need another mod for that I don't have in the build at the moment. Or maybe they got rid of it, because they did get rid of some other pre-built pieces in favor of encouraging people to do their own stuff. So it's possible the Aegina bus is gone. But regardless, getting up the XLR-81, and then we're going to have upgraded LR-89, which I think the NA3 version of the LR-105 and LR-89 is the... Let's see. Let's check the Heroic Relics page here real quick. Because I thought they had some stuff about the different Atlas iterations. Maybe it's not the Heroic Relics page. LR-89. Yeah. MA1. But I don't think we're up to the Atlas D yet. I think the Atlas D is in, like, 59 orbital rocketry. Maybe not. These are XLR-89. Which ones? 3s. 60 orbital rocketry? Yeah, okay, so 60 is the NA5. Okay, that's the MA2, which is the Atlas D. So the NA3, there it is, LR-105-3 is the MA1, which is like the proper operational Atlas in this 1958 orbital rocketry node. 56 to 57 that I have now, I think the configuration we get is not great. I'd have to check it in the... I'd have to check it in the VIB, double check exactly what the configurations are, but yeah. Something like that. The 1958 orbital rocketry, I think, is like the real Atlas. So I might go for like an Atlas Aegina as my workhorse. I might or might not build a Thor. I don't know. I've said this the past couple of streams. I really want to build a proper Atlas that KOS can fly correctly, which means dropping the boosters and all that stuff. So doing a Atlas Aegina doesn't sound like a terrible plan. All right, let's grab First Solar. Periapsis above 300 has positive energy balance and 14-day stable orbit. And 100 units of electric charge. Let's make sure that I didn't make the batteries too small. So let's open the Orbiter 2S. How big is the battery in this? I'm going to make the battery a little bit bigger because it doesn't affect our delta V that much. Oh, did I grab that contract when I was in there? I did. Okay. Let's run this sim real quick. I just want to ensure that it can... If it's looking for 100 units of charge on board the vessel, I want to make sure that we are going to achieve that. Because like our overall resources, if our max is 100 and it never gets above like 99.99999 or something like that, then I don't want to lose the contract. That's what I'm trying to say. So, stay in a specific orbit. Yeah, just a PE above 300. That's fine with this. And then I just need to skip ahead 14 days, and we should see... Yeah, that was happy. Yeah, this is the T-17 even. Wow, we way overperformed there. Contract says we're good. This says we are EC Perpetual. So we just need to skip ahead like 14 days. All right, well, that was horrible. Chatterer does not do well with lots of time warp. But resource electric charge at least 100 units and positive energy balance. Oh, because I'm in shadow. And I was probably in shadow when I started the time warp, so it got a little sad about it. But let's try to get out into the sun. There we go. We have positive energy balance. Oh, but we're like butt directly facing the sun. Oof. I wonder if it's better to try to put this on a polar trajectory, so that we never have this butt facing the sun problem. Because, yeah, we're not charging well. Arguably, we're losing charge. Oh my god. Chatterer, why? Oh, the other thing we can do is think about when we're launching, right? So that we're actually, like... If I simulate this, like... You know what? No, we're just gonna... I'm gonna go to Orbiter New. I know I tested all of this configuration for First Scientific. I'm gonna try running this going around the planet. Sorry, polar instead of the other one. I can also make the solar panels a little bigger, but then we're getting into, like, trying to figure out our... Because, yeah, we launched this one at, like, sunset, I guess. And a sunset launch didn't quite get us... We ended up with our butt facing the sun, and we weren't getting any, charge, right? So if we just kind of flip ourselves 90 degrees, then... I just time warped way too far. I hope this stabilizes in 15 seconds, or I am gonna be sad. Oh well, it's just a sim. Hey, actually, that is reasonably stable. This might not hit orbit, though. Oh, it does. Okay, cool. This is an orbit. Is it an orbit that is acceptable? Yes. How's our power balance? Perpetual. Okay. So if we fast forward again... I'm going to do like this, so we are hopefully not seeing as much flashing when I make this go faster. That's still a lot of flashing. I apologize. And how about here? Still a lot of flashing. And I really need to turn off Chatterer. But power, oh, we're disconnected. Wait until we are, oh, and we're also not in the sun at the moment. EC perpetual, okay. All right, so maybe the better choice is the... This is such a low orbit, it's very hard to time warp without the flashing, and I really apologize. All right, 18 days later, yes, we pass. Okay, so this thing just needs to go polar. That's the answer. Go polar, or go home. And I think this also hits the requirements for the other contracts as well. AP and PE. Oh no, the AP is a little low for First Scientific. So I might still need to launch that one into the other orbit and hope that it can get enough. I'll do some sims with that. But hopefully we can get it in an orbit where it's getting enough sunlight and also can... hit the requirements for its orbit. But this one is all set to revert to vehicle assembly, and we are ready to launch it using this program. We just need the early avionics and probes to be done in the next couple of months of in-game time. Okay. Complete. Yeah, getting first solar done is really going to be about having the... What am I trying to say? Having the right that getting queued? No. Did I not? Oh, I forgot to tool the new avionics. Yep. Oh, I should upgrade these too, shouldn't I? Oh, and then I gotta resim it, but I should do it. Because we also have early avionics here. And these can be like this. Tool it. That's fine. Let's sim this one more time. I'm not going to sim the whole 14-day science gathering. I just want to make sure that, like, we just shaved several kilograms. Oh, and of course it's the middle of the night. We just shaved several kilograms off the first stage avionics by switching it over. And I want to make sure that we are still hitting approximately the flight profile we care about. Yep, a little higher apoapsis, but that's not surprising. And let's realign. Yep. That was close. I fixed the time warp at, like, the last second there. All right, 1.5 kilometer AP, 535 kilometer PE. This is great. This should be able to achieve, I mean, technically it hits our goals just barely for scientific. I will probably launch the scientific into a slightly different orbit. I may still launch it inclined so that we get more science or have more electricity so science can run longer. Thus more science. Cool. We have our toolings. Launch this. All right. Added to integration. Perfect. And then as soon as we complete the satellite era science tech. I'm going to start orbital rocketry here, just so it's started. Yeah, we need basic avionics for deep space avionics. Good to know. And then... Okay, that's all we got right now, unless I want to unlock, like, plane tech, and I don't. But I'm going to start 58 orbital rocketry, because this is the stuff that I want to be working on the next ship for. Yeah, let's get this solar-powered satellite thing figured out. Double check, we have the contract. Just fast-forwarding a little bit, so all my launches aren't right at dawn, as much as a dawn launch is fun. All right. Hopefully I can, what was I trying to say? Hopefully I can figure out the YouTube built-in editing tools. I want to make sure I try to put a flashing warning on for this VOD, because it's real bad in some places. And I really don't know how to align the camera in a way that it doesn't do that, unfortunately. What I do want to try to do, though, is see if I can find, like, chatterer settings. Are you chatterer? Yes. So I can mute you. And hopefully that fixes some of the, like, gain and loss of signal constant noise. I'm not sure if that's actually Chatterer or if that's a Kerbalism thing that's doing that, but either way. Yeah, this didn't quite hit 1.5 this time, so I want to make sure that I have a little more breathing room when I do First Scientific. Alright, I gotta warp ahead for those 14 days. We're gonna be zoomed in on the ship. We're gonna look at space as much as possible. It's still gonna flash. I'm sorry. Alright, 15 days. Our electric charge is low. That doesn't bode well. I may not have been in the right situation to charge when we came around before. Let's just loop around and see if we can get this thing charged up again. I'm gonna be real sad if this doesn't work. All right, there we go. We're like side on. We should be charging. let's physics warp this so that we're not in any of Kerbalism's weird on-rails behavior. All right. 2. This needs to go up to 100. Hopefully it will do so before we go around the planet again. I'm nervous. I time warped too aggressively with the ship not in light, and Kerbalism gets weird about solar panels when you're on rails. Like, it's working fine here. For... Yeah, are we recharging though? Okay, we are recharging now. I just time warped too fast. So every orbit we're getting a little higher, and this just has to go back up to 100. I was gonna say, its battery is plenty big to make it around. There we go. Contract complete. First solar-powered satellite. Yay! Back to the Space Center. Now we should be able to grab first scientific and atmospheric analysis. And we're going to warp to, well, getting the number of researchers we want. We're going to warp to Satellite Era Science. We're going to go to the VAB. We're going to take this to S. We're going to add... We're going to do two things. We're going to go in here, and we're going to configure experiments. There we go. We're going to take the mass spectrometer off, because it's not helpful. And we're going to switch it to... Hello? Turn off experimental. Oh, I was too fast. We're at like 99.999% complete on the science research. Ah. There we go. Now we can do it. The question is, how much other science can we slap into this thing? Well, not a lot, because I need to bring along thermometer and barometer, but I should be able to bring along at least one other experiment, right? Yeah, cosmic ray science, and the magnetometer's kind of heavy. Ooh, yeah, look at that. Look at our delta V when we add the magnetometer. Mass spectrometer, we're done. Micrometeorite detector's pretty light. It runs over the course of 90 days. Sure, why not? See how that works. And then I'm going to change the script in this. Instead of doing like a retrograde one, I still want to be not fully flat. I want to be inclined so that we have a better chance of the solar panels working well. But let's do like a 60-degree orbit. And let's sim this. And this is the Orbiter 2 Psi. And hopefully this can hit what we need. I didn't check what time it is outside. I wasn't paying attention. Chances are it's night. It's always night. We're going to do 13 hours from now. I called it. It was night. All right, so this is going to tilt itself over at like a 45-degree inclination. Yeah, and then it does that weird jerky thing, which I don't care about as long as it works. And then once we're in space, I can force run the pressure scan and whatever. All right, 540. That is going to be fine for our PE as long as I can get the AP above 1.5. Get this thing aligned. Try to remember to turn off the time warp before we deploy the satellite. See how we do there. And I picked 45 totally arbitrarily as my inclination, by the way. The goal is just to have some inclination so that my probe is sideways relative to the, shoot. I just missed the time, and we might be a little screwed on our orbital parameters here. Yeah, I want to rerun this because I want to make sure I can trust the results of the sim. Transmit 1 day's worth of cosmic ray science. Yeah, because it doesn't have a day's worth of power unless it's in the sun. So I want to make sure that I have the sun set up right. So we're going to do this launch one more time. I'm going to try to actually fix the time warp at the right time this time. I'm going to be real excited when we don't have spin-stabilized rockets and physics warp is not as dangerous. But if I'm following a realistic American tech progression, which I'm not really necessarily trying to do, I'm just doing it because those are the missions that I know, and I'm replicating like what I know from real life. But a lot of that stuff will have more solids, more spin stabilization. That's just the early American rocket way. And there were reasons for that. One of them being that the U.S. military moved away from hypergolics in rocket-based weaponry to almost exclusively solids. So we have a lot of solid just technology in the U.S. compared to the Soviet Union that stuck with hypergolics for more applications for longer. 3, 2, 1. Stop the time warp. And go. Oh, and I forgot to actually turn on the new science, didn't I? Cosmic ray science and micrometeorite. Yeah, okay, so when this works correctly, plenty of delta V. We're looking at like 3,000 by 600, so this should satisfy both contracts. Yes. I need to force run pressure scan, info, forced run, temperature scan, info, forced run. Oh, and did that finish? Recover or transmit. Okay, so it has to run the whole however long temperature scan takes, a few minutes. And then for this one, we need a 24-hour stable orbit and a day's worth of cosmic ray science. So let's... Atmospheric analysis finished. Altitude record. Cosmic ray science is still waiting for a couple of hours. Stable orbit confirmed. Now we're just waiting for the science to transfer. There it goes. Perfect. Scientific and finishing the program. That is exactly what I wanted to see. This is it. This is the rocket. I'm going to run this one completely unfast forwarded to orbit, and then we're going to fast forward through the first 24 hours so that we can claim the contract and the program completion. Yeah, there's nothing to do here except turn on the science by default so I don't forget. Cool. To Psi, added to integration list. There it is. Beautiful sunny afternoon for a launch. Love to see it. Well, this ended up being a long stream, but I'm glad I got all this wrapped up. The Jupiter or Juno, or, I mean, it's a Redstone variant, really, is working fantastically. I've been really happy with how this has gone as a launch vehicle. It's been incredibly reliable. I don't think I've had a single failure, and I know I just jinxed it, but, like, we're up to almost full DU on this engine, and it has never blown up on me. Which is really just wild. I think my last screenshot was basically this, so I need to figure out, make sure my my YouTube thumbnail looks good. Because I've been using the same rocket, I have nothing new to show off with the thumbnail. Yeah, the thumbnail is one of these. I think it's the stubbier version, but still. I might do a zoom in on the satellite itself and make that the thumbnail. The satellite glinting in the sun. Not really sure yet. All right, 540 looks good. I'm not going to make us wait 5 minutes of real time though. I will accelerate through this part just a little bit. Not as fast as I've done some of them, but these launches in real time can be, 10 minutes. So time warp is really nice. All right, and then we'll do 2x time warp while we're waiting for it to stabilize here. So yeah, the stretched, the sort of uprated orbiter, we no longer need the in-between stage. We've got plenty of Delta V, and we haven't even switched to the new, the uprated Baby Sergeants. We're still using the original. So getting to 1958 tech, which I don't think there's another engine upgrade for this. I think this is pretty much the end with the A6H. This is as good as it gets. But we could potentially still use the, the Sergeant cluster. I do have leaders that give me buffs to solids, so I do want to be figuring out how to use them effectively. Which, as much as I keep saying I want to build an Atlas, now that I'm thinking about, like, what's the right thing to do from a gameplay perspective, the right thing to do from a gameplay perspective is probably to build a Thor, keep using solids for my upper stages, and all right, so I need the 24-hour stable orbit, and I need to retransmit the science. So let's do that. Pressure scan, forced run. Temperature scan, forced run. And cosmic ray science is running. Micrometeorite detection is running. Both of those take 90 days. So we're going to get very little of that science from here. They really need to be running, in the background, right? Which is what Kerbalism gives us. All right. Once again, flashing warning. I'm going to time warp up to through 2 weeks. Oh, this can probably stop doing a forced run. Stop. Nope, maybe not. Oh, because I'm time warped. I can't do anything. I'm time warped. Stop. No? Oh, and now I have no signal. Of course. Okay. Now can I stop these? Yes. All right. And now we do the fast forward for 14 days. Oh, not 14 days. This only needed 1 day. The other one needed 14 days. First scientific, leaders available. Contract complete. Okay. This only needed 1 day, not 14 days. I forgot which contract I was doing. Let's make sure when we leave this, 100% EC, perpetual. These are both running fine. So yeah, we can go to the tracking, Space Center. We're going to the tracking station and then to the Space Center. And I can complete this program, and then we will have to figure out what our orbiter psi at its nice 45-degree orbiter 2s, and I'm not sure why it's only showing me one of them. Oh, probably because I was not fully into... Here we go. If I go back here now, can I see the psi, the S, and the original 2? All right, there we go. There they are. Oh, and this one's got some real wobble to it, but that's just it's not actually wobbling. It's because of the inclination relative to the Earth and Earth's rotation and stuff like that. It only looks like it's wobbling from certain perspectives. All right, we can complete this program. Done and done. So these ones look like they're going to have a lot of science, so that is worth grabbing. Early commercial, I want to grab, and early lunar probes. I'm going to grab all three. Early lunar probes within 4 years? Or push it out to 6? I'm going to push lunar probes out to 6. Just because I'm not convinced I'm going to push on lunar right away. I think I still need to learn a lot more about writing launch scripts and other stuff first. But yeah, this is it. We've got early commercial applications, Earth observation satellites. So the two of these together are going to give us a huge amount of budget now, plus early lunar probes. You know, we're looking at... All right, this one's kind of funky shaped, but the other ones are... Yeah, $270,000 a year for the next 4 years, which is a fantastic budget for me, I think. Yeah, I'm making $1,000 a day right now. Excellent. Admittedly, not building any rockets at the moment, so gotta fix that. And we do need to grab our next... I need this for the tracking station upgrade. I'm gonna grab it. It's not necessarily the most important tech, and I can always move it, but... Yeah. All right. I'm happy. I really wanted to have this goal done last week, so I'm glad I got it done this week. Finally. Only a week late. End of December 1958, we've done it. So Explorer 1 was late, but I think whatever satellite that the first... atmospheric analysis satellite... I think we were early on this because we rolled it into our Explorer 1 launch and did some other stuff. But yeah, thank you very much, everybody who tuned in, and thank you to everyone who watches these on YouTube. It's always appreciated. Tomorrow, that's Thursday, so today, if you're watching the YouTube VOD on the day it comes out, I'm doing my normal Pyanodon stream, and then after dinner, I will be starting Blueprints live on stream. I've been super excited for this game since the demo came out a year ago. And I am really excited to explore it with everybody. So I'm going to be doing that, and I'm going to be doing it for my wildcard game on Friday as well. And it'll probably be my wildcard Friday game for a little while, at least as long as I can avoid spoilers. And maybe some bonus streams in there too. We'll see how much time I end up feeling like I want to sink into it. I suspect it could be one of those games that I want to sink a lot of time into. So if you're interested in that, check it out Thursday, evening on my stream, or of course it will be posted on YouTube afterwards. And I think that's it. So once again, thank you everybody, and I will see you tomorrow.